my every move and then helping out. You are my sons, my brothers too, and always will be. Shout it out, turn it up, tonight's the night, boys. Scream it out, smash it up, it's time to create noise.
Jason, are you ready for Slug Me?
Yeah, let's get it. Dude, you said this was Wasteland attire.
Yikes. Sorry, dude. Think the face paint might have been a bit much.
Yeah, really?
Every SOLIDWORKS user that I deal with on a daily basis is passionate about what their career, they're passionate about the software, and they love to actually use it. My favorite part of the community is just getting together, hanging out with everybody, seeing what they're passionate about and seeing what they're designing. Kind of gives you a new appreciation of how things are engineered, how things are designed, and you might even get to see things out in the field that your friends or your acquaintances have created.
I think the community as a whole is always changing and always pressing for things to be better in a lot of ways. Just crazy intelligent, the entire community as a whole. We're constantly striving for more. Like, we are in all kinds of industries. We're in all kinds of fields. Like, we are in science, we're in math, we are in food processes, we're in fluid mechanics. There's a bunch of us everywhere.
I love to sit and watch that light bulb go off when somebody gets something that you're trying to help them with or walk them through and showing them a different method to do something or things of that nature. It's just, there's so much gratification in sharing what knowledge that you have. That to me is worth it no matter how much time and effort it takes.
If I see someone that has an interest or looking like a deer in a headlight, that they're just overwhelmed, then that's when I engage, because I've been there, right? So I'm like, it's okay. Just chill out, calm down. It's gonna come to you. Don't try to take it in all day. Take your time. What I've gained has been over several years. You will get there. Just be patient with it, keep engaging, keep networking. And that's what the community is all about.
So I think with as diverse a community as we are, we really are just making the world a better place one by one, and I think it's beautiful. I think it's just fascinating and beautiful to be a part of this community. All of us individually offer so much, and I love getting to know other people in this community who have the same passions I do, and we get upset when a spline isn't the way we want it to be in SolidWorks. But it's great.
IronSwug is a chance to share the enthusiasm about the everyday software we use.
It is a chance for us to get out, see the users, interact, and present SolidWorks topics in multiple states.
In places like Nashville,
Elizabethtown,
Indianapolis,
Milwaukee,
and Arcadia, Wisconsin.
I'm Dave Mandel. I'm the user group leader for SMART in Milwaukee. I love being part of the SolidWorks user group network, mostly just because it gives me a chance to kind of engage with my fellow SolidWorks nerds.
Thank you to all the users that made it in person and the ones that joined us on the Zoom call. Not only did you come with good questions and comments, but you make it more exciting for Adam and I when we have user participation.
Without you guys, there would be no IronSwug.
And the swagging is always about the connection.
I love coming to these events. It's about networking, seeing old friends, making new friends, sharing tips and tricks, learning something new. Been doing this forever, seems like, but every time I come to one of these kind of sessions, I go home with something fresh every time.
I would like to thank the local SolidWorks user group leaders that help us plan and execute these meetings.
Those local boots on the ground, without them, this is not possible.
I got like the opportunity to come here to attend the IronSwug meeting. It's kind of like a big different event, you know, meeting a lot of people, learning about like new stuff. The cool thing like that I love about swagging is kind of like the different perspective for using SolidWorks and 3D Experience platform.
IronSwug and Swug benefits the community by allowing users to come together and share the passion they have.
Community here is kind of different. You're gonna find like free tips and tricks, a ton of experience. This is kind of like a huge like gap of knowledge that you couldn't like find without practicing, or you got like knowledge. And even they are certified. They're certified expert. They know the program.
I'd like to thank all of our sponsors for making this happen.
That's another group of people that without this we can't make it happen.
The swagging, and it's kind of like a game changer. I encourage everybody to try to get involved. It's kind of cool.
That's it. Milwaukee's a wrap.
It's a wrap.
Welcome to What's New in SOLIDWORKS 2025, hosted by SOLIDWORKS Live. We'll be uncovering the biggest enhancements within the SOLIDWORKS 2025 release. In SOLIDWORKS 2025, we trust that you'll enjoy for many months and years to come new features and improvements that will help you accelerate your product development with tons of designer-driven enhancements to the industry standard in collaborative 3D design.
Each area of our product was challenged with deliver a big, impactful difference. The vision we have is to support our customers end to end, right? So from the early ideation or even marketing research through design, which is what SOLIDWORKS largely focuses on, all the way through manufacturing and beyond.
And the team is really obsessed with enhancing the product in the way that our users want it enhanced. So to do that, we have to do a tremendous amount of listening.
This part has over 26,000 triangles, which means that curved faces appear smooth, but it also means that maybe the part performance is reduced. Sometimes faces with tight curvature are a common culprit, and this variable fillet is a little bit pinched. So in 2025, I'm going to use the new continuous edge blend option to kind of smooth that out.
Now in 2025, we have new enhancements like breadcrumb selections. This is awesome because you can go through and navigate the hierarchy of that assembly. Now, you'll also see that interference detection in 2025 is now supported for that LDR mode. This is a really awesome enhancement if you're working on big assemblies. You need to check for major interferences. Before, you could only do this when it was resolved. We'll see support here.
So one of the things right off the bat is just from a UI perspective. On the command manager, you can now add SOLIDWORKS PDM tab to your toolbar. It's fully populated with all those kind of common commands like the get command. What's new about this in 2025 is one, added the revision column, and two, anywhere you access the get command, you can now check out your designs.
This year, we included a new option in Detailed Cut List where you can actually calculate the quantity based on the BOM quantity. So this is just another development to make it possible to do anything you can do in a detailed cut list in a normal bill of materials now.
Now, as a mechanical engineer, I want to be able to determine, are my connectors and cables going to be able to fit? Are the clearances sufficient? Like, how much room is there in and around the mechanisms and the enclosures? And of course, what about finger clearances during assembly?
Sometimes you don't just want to exclude one part. You might have 50 parts and you only want to simulate 3 of them. Well, instead of suppressing 47 parts, you can now pick the parts that you need and then right-click and say exclude others.
Certainly there are times when you're just working in SOLIDWORKS and it's like, I just need to spiff this up for a presentation or for the website. I don't want to have to, suddenly right now I've never used Visualize, jump into a new tool and figure out where all the buttons are. And this year we've added something that will actually help in that area. We've added API access to Visualize. So in this example that you see here, I'm using a macro to just do a background render directly out of SOLIDWORKS. This is API access, so you can customize this exactly to the way that you want to use it. Again, this is just an example, but you can see this is a very common scenario where you're just working along and say, I suddenly need something for a presentation. I just swipe over, I get my rendering to whatever folder I've set it to, and then I can just drag and drop those into my presentation and head over to my meeting.
Thank you to all of you. First, for your continued choice to leverage SOLIDWORKS in helping to make your amazing designs come to life. And secondly, for making this worldwide design community what it is today.
Welcome everybody. Here we are, Slug Me 9. We're live from Waltham. Guys, I can't believe we're sitting here once again, October 24th. We've been looking forward to this for quite a while, right?
All year, all year.
About a year or so. It feels seriously like yesterday. We were sitting right here last year for Slug Me 8.
I was there.
Oh yeah,
You're still the same. I don't know.
Were
Yeah,
switched possibly. But hey, let's do some intros. I'm Dan Wagner. Who are you, sir?
I'm Eric Beatty.
Todd Blacksher.
we're here to help you kick off your Slug Me journey today. If maybe we have some first timers, hopefully we got some new people joining us. We definitely have a lot of familiar names in the chat already. We saw some of our friends already joined us for today. We've been sharing this event with our community for quite a while, right? We've been building this up. So we hope our SolidWorks user group leaders, our SolidWorks champions are out there. Other people from the community, we hope you're joining us. And if this is your first Slug Me, let us know in the chat, right?
Yes.
Give us a shout out. Let us know
where you're from.
Yeah, let us know where you're from, and maybe let us know how you found this. How did you stumble across Slug Me? We've been growing this event every year. We have an amazing story to share with you all today.
Indeed.
And we got a big show in store for you. Guys, we couldn't do this though without our sponsors, right?
Yeah. Big help.
This is a big production. When you see what's behind these cameras and what goes into an event of this scale, we need help, right? So Dell and NVIDIA came in huge this year to help us out quite a bit with this event. We'll talk about them more in a moment. Metalworks, Todd, your company.
Got an amazing team, and they made a couple of parts for the trike that we're going to look at later, and just beautiful parts.
Awesome. Orbital FX, we have Luke here. Luke's going to take us through some pretty awesome, again, advanced makers strategies later on. I don't want to spoil any of the surprises, but we got a lot of support from Luke's company. Trimec Group, 3D Print UK, so much support from Kirby, the rest of the team there, with a lot of really great rapid prototyping parts. Awesome. We really appreciate their support. And Eric, how about Omax?
Omax made a few parts to contribute to this effort as well.
Awesome. Yeah, we can't wait to see those as well. So big thanks to our sponsors. Specifically, I had a chance to sit down yesterday right here with Matt from Dell. He stopped in to kind of chat with us a little bit. Let's take a look at that video now. All right, we're live here at Slug Me. I'm happy to say we have Matt from Dell here supporting the event.
Yep, couldn't be happier to be here. Slug Me is going to be awesome today. I saw a little bit of the footage, and it's really amazing. We support Slug Me and the SWUG more broadly, that we meaning Dell Technologies and NVIDIA. We have a huge interest in what your users do and support them with Dell Precision Workstations. And some of you may know Dell has a rugged line of products which are awesome for on the manufacturing floor, in the field, or in the parking lot where you were driving the machine yesterday.
You saw some of these machines going sideways out there. We probably could have used some of those rugged machines.
Yep, and those new rugged machines, they actually support NVIDIA RTX professional graphics. So like using them with eDrawings, it'll be pretty snappy.
Oh, great, cool. We're doing a giveaway too, right?
Oh yeah, that's right, that's right. So we're happy, Dell and NVIDIA happy to sponsor along with a Dell Precision 5690 mobile workstation. That's a thin and light mobile workstation with RTX professional graphics, and there's a QR code, right?
Yep, in just a moment we'll show a QR code on the screen, scan that, enter for your chance to win.
Yeah, get your name in there. It's going to be an awesome prize.
Well, Matt, again, thanks for your support. We appreciate you being here. Everybody hang on one more moment. We're going to roll one more word from Dell and get back to the show.
When you need faster speeds to draw predictive analytics from data, greater flexibility to transform your creative work into impactful stories, and more innovation to craft code into intelligence, the power is in your hands with the new AI-ready Dell Precision Workstations.
All right. We just heard from Matt at Dell. Again, so happy to have their support. You saw it from him. You see it down in the description for the video as well. You have a chance to win a Precision mobile workstation.
Yeah. And both Eric and I are huge believers in the Precision Workstations.
Well, for over 20 years for me, and I know it's about the same for you.
Yeah, because when we were talking about this the other day, we were joking, and the manufacture date of the first Dell that I bought was 111000 11/10/2000.
That's awesome.
I bought a lot since then.
Same.
Awesome. Well, again, thanks for the support. Check that out in the chat. Scan that QR code as well. Guys, 3D Experience World's coming up, right? We're here. I feel like this is our Super Bowl. This is the SWUGin' Super Bowl, right?
For me, it's Daytona 500.
Yeah, Daytona 500. But we all look forward to 3D Experience World. This is coming up here in February in Houston. We're back in Texas, which is going to be a lot of fun. Eric, you going this year?
I'm definitely going, and I've submitted 3 presentations, so I'm keeping my fingers crossed that.
Awesome.
Yeah.
I've heard some whispers too among the crew here that so much of what we've done today could actually kind of spider off into 3D Experience World presentations, which is really cool too, that SlugMe will kind of be connected to World. And I'm really pushing some of the data you see today, some of these builds we see today, we're going to have physically at World too. So if you like what you see on this session, hopefully you'll get to see it in person in Houston as well.
Oh, that'll be amazing.
Registration's open. Register now.
Yep.
The SolidWorks for Makers offer, guys, I wanted to chat about this with you for a couple moments here.
Oh, you know me, I love the Makers offer. I'm probably its #1 biggest fan. I'm trying to promote it and support it as much as I can on the forums, on social media. I'm gonna say it. It's a hell of a deal.
And it's even better now.
It is.
Now we have a discount for this event.
That's right. If you check the description for the video today, we're offering a discount for 3D Experience SolidWorks for Makers for anybody watching SlugMe 9 with us live today. Eric, I feel like, as a maker, right, if you're looking for a software tool, you might not have the budget right out of the gate for SolidWorks, right, for production SolidWorks. This is such a great solution for those folks.
Oh my gosh.
But I think a question that comes up a lot is, what if I need help? What if I get stuck somewhere? If I'm modeling a part, where do people go for that?
Well, swim.3ds.com will take you to all the SolidWorks communities. And there is the general SolidWorks user forum, but there's also dedicated maker support community and a made in 3D community for you to show off your stuff.
Yes.
And there's some phenomenal builds that people have posted in there.
And if you spend any time there at all, you'll pretty much just see Eric pasted across the entire. He spends so much time there. He does. Eric, you do the community a huge service with the amount of time and effort you put in there. So we really appreciate that.
It's just something I really believe in. Almost from day one, I thought that, there needs to be a SolidWorks for everyone. A couple years back, the tagline was SolidWorks is everywhere. Now SolidWorks is for everyone.
That's cool. I like that.
I think that's part of the reason Eric's not wearing one of these shirts.
Yeah.
He's got a special shirt on.
Yeah, I don't know, if everybody else out there knows that, but I'm sitting next to a one-time champion of the year, man, 2023, right? 2023 champion of the year, which is pretty high honor. And Eric, again, it's an honor to have you up here, man.
It's an honor to be here with you fellas, the Swuggin' Top boss, and the father of SlugMe.
Father of SlugMe. I want to mention one other thing about the Makers offer here. Like, if you roll back to what we did last year, and we're going to talk about that more in a second, that was an entry-level maker, right? It was, what can I do in my garage with woodworking and maybe some Jesmonite sculpting and some sanding, right? And
Chicken wire,
right? We stepped it up a notch this year.
Two,
yeah. This is still Makers. The story we're going to tell today that this amazing team is going to take us through is more of the advanced maker, right? If I'm in my garage still, but I start to source parts from vendors, I get CAD data from really skilled partners, which we'll talk about today. Maybe I collaborate with some friends, right, who are using the same software in other areas. What can I accomplish still, again, if you're using the most of what you will see today? Most of the software shown today is actually in the Makers offer, which is really awesome.
For $48 a year, or actually $38 a year with
20% off.
The special discount.
I wasn't going to do that math live, so I appreciate you doing that for me, Eric.
That's why I'm champion.
Yeah. All right.
I'm a mathlete.
Another QR code for you. We started a LinkedIn group for the User Group Network earlier this year, and Matthew Hall has been managing this. This is approaching 900 members. I just checked this a little bit ago. We're a little over 850. We want to make sure that everybody knows that between user group meetings, right? There's not a SlugMe every week. There's not a user group meeting every week, right? If you're a member of a group and you're, somewhere and you're like, hey, I'm looking for more content. I'm looking for a way to connect with other user group members and leaders all over the world. This is a new space that we're trying to do that. It's just one of the spaces, right?
It's great for networking. It's really another source of, forum support, technical support.
Exactly.
It's a good way to find vendors too. Because I mean, you're
Indeed.
talking with people with different companies, and
point.
it's like, okay, I work with sheet metal, but I don't do much with injection molding. So if I have questions, I know this person from the group.
Yep.
I can hit them up.
Something that we've realized, of course, right? We can't go one place to reach people.
Right.
Not everybody is in any one area, right? So we're changing up our approach a little bit and trying to reach new people, new user group members in different spaces. This is one of them. The LinkedIn space is really working well, and we hope everybody can join that group. Matthew Hall is also working on a Discord server. So if you're a Discord user, you're going to start seeing User Group Network content pop up there. And we can share that in the chat as well if we wanted to link to
There's
the
folks
Discord
on
server.
Reddit as well. I've even seen
Yeah,
some
that's a great point.
Instagrammers.
Yep, Instagrammers for sure.
Yeah.
All right, so Todd, let's break this down, right? If we have anybody new with us today, I hope we have new people. I haven't checked the chat yet. Maybe we can get some hands in the room if we got any new people in the chat. But if you're new here, if this is your first Slug Me, what is this? What did we stumble upon, Todd?
So it's really about the community. You know, it's all the users. We all get together at World. We hang out. We get to know each other. But that's the only time each year that we get to see each other. And so this was like, okay, you know, Eric and I chat online all the time.
Constantly.
But I only see him in person like once or twice a year.
Right.
You know, World year. And Slug Me was a way to make that happen on a smaller scale in between worlds.
Right.
You know, so it's like, okay, we're going to go to World in February, but there's this big dry space in between Februarys.
For sure.
And so I needed to get my, you know, fellow SolidWorks junkie fix and hang out with people again.
Right.
And so we just decided to start doing this, and it was like, okay, we're going to have like a really great presenter. We're going to have all the user groups get together, tune into the same presentation, and we're just going to count that tally up.
When was this, Todd?
9 years ago.
So
Nine.
way before COVID.
Yeah.
Way before Zoom, Teams, virtual meetings, virtual calls were a thing.
Well, and it all built like on the old forum. So it'd be like if we just built something like this on Swim now, and it was just, hey guys, what do you think about this? You know, what if we did this? Because it's, you know, it's a big community. Like, Eric, did you send Kendra a happy birthday?
I did not, but I do know that her group, Panama City Swag, is getting back
Meeting
together tonight
to watch this.
Yep.
So shout out to Panama City Beach.
Hey, Kendra, and happy birthday.
I thought she was walking in.
Oh,
that'd be Joe Lance.
Yeah.
Surprised Joe was in here.
So yeah, I mean, we had just a crazy success that first year because it just kind of very grassroots level. We kept, you know, groups kept going, yeah, we'll check it out. We'll check it out. And we pulled a lot of data, and there were 740 people attending meetings all over the world.
So like 30 some groups.
Yeah, 33 groups.
33.
You know, I was like, hey, if we get 5 groups in this, it'd be awesome. Or 33.
So basically, you know, outside of World, outside of regular user group meetings, something really big everybody can look forward to.
Yes.
Trying to get as many people together as possible.
Some type of dynamite presenter like Tom Cody
Yes.
or Todd Blacksher.
Fast forward a little bit, right? Fast forward a little bit, and I joined you guys, I think, towards the tail end of Slug Me 5. That was already planned and done in 2020. And then our first chance, our first big party was Slug Me 6, right?
And
The chance
we
to
were
get
going to just, you know, really break you in.
Right.
Yeah.
They decided, oh, for your first Slug Me, let's do a 24-hour plus broadcast. So if you didn't know that already, yeah, we went and did a 24-plus hour
25 hours and 20 minutes.
Unbelievable. Right here in this building, we stayed here and did a crazy broadcast overnight. And it was a lot of fun. We didn't want to relive that.
No,
Today will be a little
We
shorter.
proved it could be done, and we moved on.
That's all we had to do.
Slug Me 7, we started to get into more charitable projects, which was a lot of fun, right? We pulled in Magic Wheelchair, Peruvian Hearts, Armed for All. We had a chance to kind of work with all of these different groups.
And we went totally global with that as
Yes,
well. I
totally
think we
global.
involved 5 continents.
And I would say that's our first year. We really got this core design team that you're going to see today heavily involved, right? It was like, this is the team we're going to pull in and help us design something pretty crazy. And we even got to design and create this really awesome desk for Jenica, right? And then,
was
guys, I had the
amazing.
honor to go to her house with Jeremy Fielding and
And set it
install it
up.
in her house. That
I tell you,
was
Todd and I had some
Yeah.
serious FOMO over
Yeah.
that
Yeah.
when you guys were there.
just unbelievable, right? For me,
it was just amazing because like you were sharing pictures with us as you were doing it.
Oh,
And it was
man.
like, yeah, we're missing out on something really
pollen
cool.
count was spiking in my area. You know, I
Very-
couldn't keep my eyes dry
Yeah, it
seeing
was
those
a
pictures.
very humbling experience for sure. She's an awesome person. She's actually kept me up to date too. She has sent pictures since then.
Nice.
She's using the desk.
Oh,
and-
that's
yeah,
too cool.
it's really cool. Last year was our first year taking Slug Me into the maker space,
Yes.
right? We were right here. We're sitting right here
Yep,
last year.
same place.
And we got to build, if maybe if you haven't seen this out there, we built a lending library, right? If you have something like this in your neighborhood, it's you could take a book, you could leave a book. It's just kind of like a neighborhood book library.
Mini community library.
Mini community
Yeah.
library. And
Somewhere. And it was very
it
whimsical.
was very
Yes.
whimsical was the term, right? We had some advanced woodworking, some routing, some sculpting. Go back and watch that. That was a blast, guys. And again, I come back to like that was entry level makers, right? That was
yeah.
what you would want to do at the entry level. So this year, right? What's the story? We're now beginning to have some back history of what Slug Me is and where we're hoping to go this year, the more advanced maker. But as soon as we started talking to the team about this, Jason, Andy, Jordan, Shreyas, the whole design team, Sal and Chinlu, it's like we're probably going to need some more help with this.
Yeah.
We have a lot of talented people here, a lot of super skilled people, but when it actually comes into implementing electrical components, we needed some friends.
There's
right?
a lot of stuff
All I'm
going
going
on.
to say is Jason had some strict requirements for his participation this year. I'll let him share
Yeah.
that, but again, it necessitated bringing in some serious
Talk about a
pros.
contract writer.
Exactly.
Must have.
But he basically
Totally.
had a list of demands, right? So what my thought was, and this actually came to be at 3D Experience World, let's see if we can partner with Bowhead. We're going to roll a video in just a second, kind of explaining that story, a little bit more backstory on the data set that we ended up with this year, and hear directly from the Bowhead team how they helped us, what their reactions were. That's going to be really cool to hear that in a moment. But let's lay it out what everybody's going to see here the rest of the day, right? We're going to talk about the data set. Then as we move through this whole process, as we move through the design this year, instead of like doing all the software up front and then going to the build, you're going to see an intermingled presentation throughout the whole day.
And it's going to be the whole thing because it's going to be design, analysis, build,
Yes.
and just
Lather,
we're
rinse, repeat.
Yep, exactly. We're going to be all over the board, but you're going to be actively engaged the whole time.
Which I hope our viewers really appreciate, right?
Oh,
It's
for sure.
going to be a little bit more engaging, a lot more new faces, new approaches, and you're going to, I think, get the feel like, hey, I'm building this thing in my garage, and this is
Exactly.
how I could go about sourcing all these parts if we wanted to. So, guys, let's hear from Bowhead as to what this year's data set is and their reaction, how they helped us. When we come back from the video, our next crew sitting up here is going to be Jason and Jordan taking us through the inspiration for the bike. Slug Me 9. I'm here with Tatiana and Christian from Bowhead. Of course, the great Jason Poole here at SolidWorks. We have a bit of a story to share here of how we arrived at begging Bowhead to help us with this project and saying like, hey, we have no idea what we're doing and we definitely could use some help. So Jason, I'm going to kind of like chat with you for a second. I want to kind of talk about like how we arrived at this idea for Slug Me 9 and then the immediate step to asking Bowhead, near immediate step to asking Bowhead to help us with it. So we're in Dallas earlier this year for 3D Experience World 2024. We were in an establishment late at night. It could have been a bar, restaurant type place. Not exactly sure on that detail. But we were chatting about our plans for Slug Me. And actually, like at this point, I'm asking Jason, hey, are you going to help with Slug Me again this year? Are you in? Do you want to help with Slug Me 9 as we get into October? He's like, yeah, of course. Like, absolutely. I'm all in. But you had one requirement. Jason, I'm going to ask you if you remember what that one requirement was.
Yeah, I just wanted to make something that moves, you know? I wanted something that you could ride. That was basically it.
That was basically it. It's like, hey, dude, I'll do this, but it has to have a motor of some sort. So we started talking through like some of those details, like gas motors, of course, electric motors, different types of propulsion. But this thing needs to be indoors. We need to work on it inside. So, hey, like electric battery power fits way better with all of that, with what we want to do. And I kid you not, we're standing there. We're like, hey, that's cool, but I have no experience with building electric motors powered by batteries with, people's safety at concern, right? I don't have any experience with any of that stuff. And I don't know if you do either, Jason. The Bowhead team happened to be right near us. I said, hey, I think they know a thing or two about batteries or about electric motors. We kind of just like pivoted and said like, hey, Christian, we have an idea this year. We'd really love to chat through with you and say like, we would really appreciate some expertise in batteries and electric motor integration.
I think more than anyone, we remember that interaction, because I think we were getting ready to go, and then we got cornered by Jason, and yeah, I mean the only answer was yes, because that was our quickest way out of there. So we didn't know what we were getting into. We just had a goal in mind. But yeah, no, it was obviously we love to do everything we can with SolidWorks, and we like things that move. So
Great,
we did.
great
We
combination.
were all in. We're always all in.
Yeah, and that was my thought as well in that moment. I'm like, it's kind of like fate. You were sitting there and we were talking to Jason, and I'm like, I think this is our moment to ask for help and make this line up. Jason, can you talk to Christian for 5 minutes?
Yeah, I looked at you and Tatiana and everyone at Bowhead as partners to be able to execute this and just have a good time. And Dan was like, cracking home runs around every corner with finding different vendors and lining up all the parts to make this happen.
We make fun. It's like everyone who hops on the bike has like a stupid smile on their face within 5 minutes, and what you were describing was just another way to get to that smile.
Right.
And like in a very where it ended up in a very kid-like way, which is the best way to like get the mindset to have fun.
So we were able to source basically a rolling chassis, a rolling frame for a kind of like an adult kid big wheel. And Christian, you just said like kind of like a kid, like just having fun style. It serves no other purpose than trying to go sideways and have fun.
No one commutes on those.
No, you're not. There's no suspension. It doesn't ride nice, right? It's just like it's purely made for sliding around and having fun. So we said, let's take that frame and retrofit a Bowhead electric drivetrain to it, in addition to some extra parts, which we'll get into here in the rest of our show. But that's how we asked Bowhead for help, is like, can we source basically an appropriate sized powertrain for this thing? And then we'll do the integration. We'll figure out how to mount it. We'll do all that. But we don't know anything about the motors and the batteries and all those things, right? So Christian, you actually immediately connected me with Tatiana and said, Tatiana, chat with these guys, tell them what they need. And Tatiana, you did an awesome job of walking through everything with us and also giving us like, hey, here's your bill of material. Here's every single part you're going to need to make this work. We ordered all those parts. We got everything in, and we actually shipped it all right to Jason. Jason, what was it like for you to like receive those group of parts from Bowhead and start unboxing those things?
Yeah, it was a slam dunk. I mean, I just opened up the box and I was like, oh, what's this? Oh, this looks like a battery. Okay, cool. What's this? Oh, this is a motor. Oh, interesting. What is this? It was a Kelly controller. And I just looked at everything and I realized it had quick connects, and I just started snapping things together. And then I saw the key for the throttle, and I turned the key, and I heard a little pop, and I was like, "Uh-oh, we're on!" And then I cracked the throttle, and it's like wrapping itself around the cords on my desk. And I'm like, ah! I'm like I'm holding the motor with one hand, and I'm cracking the throttle with the other, and my wrist is like, ah! And I'm like, it's alive! It's alive!
Yeah, so Tatiana, like knowing what we asked, I guess, and like Jason unboxing this on his end, what were your initial thoughts when we're like ordering these parts and saying like, were you thinking like, hey, yeah, these guys, they're going to figure it out? Or you're like, oh, there's no way this is going to work, but here, we'll just send everything and see how it goes?
Yeah, that's a really funny question. Even when you guys were rehashing how this whole project came to be, the closest thing it reminds me of is university having capstone projects where you're put together with all of these different people and then, told to come up with something at the end. And typically in school, I mean, of course you still have your presentation and you've learned something, but it almost never actually ends up in like the thing you had intended to create. So I was pretty surprised to like send you guys all the stuff and then really not hear anything until it was put together.
Yeah, I felt like we were like a little extension of we were like the secret project on the Bowhead team working on like a very top secret design project, right? So I'm glad that worked out, and we exceeded your expectations, it sounds like. So that's that's awesome. But yeah, so for us, that was like putting us forward months and months, right? Because otherwise we would have had to source electric components, the controller, the battery, the throttle, piece all of that together, make it all work, and figure that all out on our own. And again, we want to thank the Bowhead team for literally saving us months and months and months of time that we didn't have. We did not have that time. So yeah, that went really well, right? We got all the parts, got everything fitted up. Jason, I don't know if you want to talk through any of that, like even the steps we went through assembling and putting the parts on, like any of those experiences.
Yeah, sure. We had I had Andy and Jordan come up here, and we conceptualized how to make this trike our own. Added number plates to it and different accessories, and they were able to reverse engineer the entire trike. So we have like an awesome data set inside SolidWorks connected. And it was my first time being able to work on a large project where you have different people working on different parts at the same time. So it was like when I was reloading from server on the platform and like seeing parts like come in, that was magic moment for me.
I can't wait to finish this broadcast and go through some of those components. Jason was just talking about the sprocket. We designed chain guards. We designed some other really cool things that you're going to see in today's broadcast. And Bowhead, you're going to get to see that kind of unfold as well. But I just want to ask you, like, you've seen the finished product. You've seen some of the videos, Christian, before you said the dumb smiles on people's faces. And I totally agree. You've seen some of that. We're going to roll more of it today. What are your reactions? What do you think? Like, hey, this exceeded expectations, or what are your thoughts?
Well, I'm with Tat on that. Sometimes these projects have like there's a dream, but it's often not realized. I mean, I did have a lot of faith in Jason and the SolidWorks team, but to see it done, because they're these Franken bikes, right? Like, and that's what we started making in the very beginning. And so you don't know what you're going to get. You don't know where the plan takes you. You do have the dumb smile, that's going to happen, but how it occurs, you're not sure. So as the video started rolling in, and then the questions about the gearing, and that's when we got the first glimmer of like, oh, they really want it to go fast. Like, it's not just, they just don't want to like tool around. Because I'm like, we're doing the calculations, and it's like, it should be all right. Like, it's not that bad, but it wasn't all right. Jason wanted it faster, so it was pretty. And then there was like I think it's a standing offer about like maybe one of these could go to one of our customers, and we saw the video and we're like, no.
Yeah.
This is not at all insurable.
I just want to take the last chance to really thank all three of you, because Bowhead, you completely knocked it out of the park. You were the perfect partner for this project. And from Jason, you made such a good point, not only from the physical stuff, but also the virtual end, like bringing the CAD data in, tying the whole thing together. Cannot thank you enough. We appreciate the support. And we will always rep Team Bowhead for sure here. So thank you to both of you, and Jason for everything you did for this project. We took over Jason's garage there for a good 3 months. These drift trikes were kind of spread among his shop there. So Jason, thanks for your support. You were a great partner through this project. Can't wait to tell the rest of the story here during Slug Me 9. But Bowhead, thanks for chatting with us today. And we'll see you in Houston, right? We're going to see you just in a few months in Houston.
Absolutely. Yep.
Awesome. What's up? Welcome back to Slug Me 9. I'm here with Jordan, and we got a whole lot of fun stuff to go over with you guys. Right?
Yeah,
All right.
I hope so.
Well, let's do it. What are we gonna do?
Well, first off, man, that bowhead video.
Yeah.
I just want to make sure we're not like any electrical safety issues.
good time.
Your head's not gonna start sparking with all your excitement.
I tell you what,
Please?
it was so cool, man. Unboxing all this equipment in my garage, and I'm like, what does this do? What does that do? And I just started literally snapping things together that would fit together, because the way they create it is so that you can't plug anything together that's not supposed to go together.
All right.
So with all these quick connects, so when I popped that together, it was just like awesome.
They designed it to be Jason.
Yeah.
That's
It
good.
was 100% Jason proof.
Smart
Yes.
idea. Thanks to Bowhead.
Yeah.
Shout out to them. They're
Such an amazing team.
They're really smart. Without
beyond
them, I don't think the thing would have been running the way
It would have been probably just gravity controlled. So you would have had to
We
push
would have
it
always had to roll
up a
down.
hill and then ride it down the hill. It's doable, you know. You could and that the speed is determined on the the pitch of the hill.
I got you.
So if you get a cliff, you can get going pretty fast. I think it's like 10 meters a second.
Nice.
Yeah.
Well done. You calculated that.
Yeah, I did.
Listen, it's Slug Me 9. We've done a lot of Slug Me's in the past.
Yep.
6, 7, 8.
Yeah.
And
my fourth
you
one.
said in that video the one requirement was
want something to go, something you ride, something that brings joy.
Because you have this one was like built for you, man. We got to go all out because your history is designing, customizing bikes on national TV.
Yep.
Now we just got a trike. International
Global,
TV.
the entire world. But listen, anyone that knows me knows I'm just a big kid, and everything I do in life is really just an outlet so that I can have more fun. Okay.
That's
so
fair.
and like I've always like tied that together with my creative mind and being able to design and make and just build stuff. And I wanted to work on something like selfishly. I wanted to work on something that was fun.
Yeah.
And something that, the inner kid, Jason, would want to rip, and something that goes fast and is fun and something that like doesn't intimidate anyone. Anyone can get on it. Anyone can ride it. Throttles on
Really?
the right.
You'd let your
absolutely.
You let any one of your boys ride this?
Oh no, none of my children.
All right.
These things are way too dangerous. Okay. They're very extremely violent. Lots of things happening here.
All right.
But
we do have some footage.
Wanted to have fun, man. That's what this world's all about,
All right, dude. Well, let's take a look at the design, and why don't you walk me through kind of how we got started? Like we basically spec'd out this trike and got it delivered to us, but there's a lot of customizations that we wanted to make, right?
Yeah.
I mean,
That's for
starting
sure.
with
we had to get rid of the gas motor.
Yeah.
That's no good. It's 2024, and we want to go fast quickly. So we need the torque. So we need electric. Everyone knows that. It's instant torque, and the goal here is to whip us around like ragdolls and have really no control. That's what a drift trike is all about, in my opinion.
I think we executed on
Yeah.
that. Riding that thing, there's like that throttle is sensitive, man.
It's pretty nuts. So yeah, the Kelly controller, the motor, the battery pack, these were like the first thing. We had the frame. We knew what the frame and the roller was going to be, the rolling chassis. We needed like this battery like pack. We needed a motor mount. We needed something custom that really came into it. And you know what's great for me about being involved with Slug Me is I get to work with some really talented, really smart people across the entire world. I'm not necessarily
flattered.
talking about you specifically, even though I thought your fenders that you did on this were amazing.
We'll get to
but
that.
It's also, I learned something new every time I'm around. Last year it was like the woodworking project, and Sal and Andy taught me what pocket hole joinery was all about. I had no idea what pocket hole joinery was, but you know what? I was inspired when I left here. I went home, I ripped out my entire pantry, put in beautiful shelves, all wood with pocket holes. And then my son got like a brand new room. So just because of the stuff I learned here.
That's what Slug Me is about.
Oh, it's awesome.
And that's why I love the focus on the maker. We got the maker license. Eric mentioned $48, now $38 a year. Like there's no excuse not to get it. But after that, like the seat was pretty comfortable actually. But you had an
It's just
idea
plain.
for an alternative design.
Yeah.
Make it pop out,
Why not?
electrify it a little bit with
Yeah,
the
this is
design.
a quick sketch that I jumped on in the garage, and just kind of an idea of like a race seat, do something a little bit more, and then you took it to the next level in X shape and brought it to life, which is really cool. And that's what another thing is like my entire career, it's really been a closed ecosystem of what can you create, and a lot of pressure there. But like when I'm able to work with the Slug Me team, it's like you have all this creative energy all around you, and people are coming up with things, and it's just awesome watching the whole trike develop, from just
The
idea.
craziest idea that we had throughout this whole project is letting Jason be kind of like the product director.
Yeah.
And actually assigning us all tasks and organizing this whole thing.
Yeah.
Building the foundational plan and figuring out who is going to build what. I cannot believe we gave you that title, but it actually all worked out.
It was a good time.
You figured it out.
I mean,
using like the tasks on the platform.
Wait till you see the
Actually
product.
pretty easy.
Yeah, the product, it's all, the proof is right there, when you're on it and you're riding it. And it's one of those things that, I'm thrilled to be part of. Slug Me is awesome,
So yeah, we made placeholders for the gut protector. We'll learn what that is, the chain guard, the front fender, the rear fender, and many more. And we had an amazing team to help us here today. Shout out to all these guys for working really hard. Listen, this whole Slug Me event is just like any other user group. You kind of use your spare time outside of work hours to make this happen. So we're all hustling, and shout out to everyone's effort.
And I think that's what makes it so special, is that it's not, we don't have to do this. We don't have to, no one's forcing us to do this. It's the passion that bleeds through, and that creative energy that gets just poured into this project that makes it like naturally awesome to be part of and to witness,
It's
just
fun. The amount of times per day Jason's head catches on electrical fires is out of control. So here it is, man. That's our trike.
Love it. I love the front fender. Like, it's like a modified dirt bike looking fender. The number plate, like, I'm a sucker for that old school BMX feel.
Yeah.
And like it screams fun. Like I
want to
this
jump on
rendering,
that,
which
right?
looks great, by the way. I love the rendering, and I want to jump on it and ride. That's what I want to do. I want to smack curbs Ian style. I want to go for it.
The crazy thing about this is we're all working remotely. We're all working in our spare time. We're not like really coordinating totally with each other. So a lot of this is like a crazy collage of people doing all kinds of weird things, and we brought it all together and hoped it looked cool. And I think it looks pretty awesome. So we're going to go through each one of these sections today. And I think the first up to bat is going to be the most important.
Yeah.
This thing's got to move, right, Jason?
Yeah. All these parts came in. What's going to hold that motor down? What's going to harness that battery pack? Like what I call the mega mount. It's really the most important part, because this puppy doesn't roll without this. So that's when we
it's got to space the chain from the axle, the sprockets, everything. It's got to connect up right.
Definitely got some help with this. This is all Todd Blackshear. So
all right,
had him come in, do some crazy sheet metal, and I think that's the first. That's the first stop. After the frame and chassis, it's all great, but it's about the motor mount.
Let's jump over to Todd and welcome him up on back to the stage, I guess, and show us what you did, man.
Yep. And we're also going to grab Shreyas up here too to do some.
He's got to check Todd's work.
Simulation.
Yeah. That's right, Jason.
What's up?
It's going.
It's going. I think.
Good.
Totally. Yeah. Good. Always good.
Yeah. So let's kind of like get into this. Like, how did it all come about? And you are the big fan of 3D lane board.
Huge.
And I think you made me fall in love with it.
Yeah.
I do want to change the name. I want to call it Spaghetti Wall.
Yeah.
Because it's what we throw ideas at.
Yeah.
And but I love this because you can throw mad stuff up there and I can, edit it and put notes on it and say, I like this. I don't like that. What about this? And so that's where a lot of our collaboration happened.
Yeah. It connects the entire team because everyone's looking at that one whiteboard, that digital whiteboard, the huge wall, which is 3D lean. And I use it for all my independent projects as well, because I save links to valuable resources on how to do something. I save links to materials I need to buy later and supplies. And it's also all my concept sketches. I just dump there, even the really stupid ones. I put there of what not to do. And the renderings, things like that, it just helps. I build like a style board, you know, like an art board along the way, even if it's a cool car that I saw or something that I like the color of. I copy it usually to the art board.
And you can kind of move it along, and it's like, okay, I like this. Let's put this
Yeah,
over
it's
here.
linear.
Just
Yeah, it goes
notes
right
and
across.
everywhere. And I'm a very linear
And I
person.
can stay up to date with what you guys are up to.
Right. Yeah.
But even from the basic step
Yeah,
one
'cause
on
when
the
we're-
sketches, right? How are you guys going about your designs?
Even when we're coming up with just crazy ideas. And so we had this whole drift trike board. And I remember this call because it was when we were talking about going from the gas motor to the electrical motor. And it's like, okay, the big difference is gas motor mounts flat and the drivetrain comes out this way. Electric motor mounts like this and the drivetrain comes out this way.
Right.
So our plate's here, and you threw up this sketch. It's like, okay, we need this tombstone looking thing, and we're going to weld it on. And everybody's like, okay, yeah, we'll get that drawn up, and we're going to send it out, and this place will do it, and this place can do it. And we can, there's all these different places for end users that can send stuff out to get cut. But at the time, I'm like, guys, I work for Metalworks. Our slogan's all things metal. We have 6 facilities covering 250,000 square feet. We've got lasers, punches. We've got a complete machine shop. We've got all this stuff. Let me take this and I'll get back to you.
Right.
And so here's kind of what I did. And this is just a short video. And what this is showing, it's not related to this, but it's how I think and like kind of where that design inspiration comes from. Do you remember like that one thing in your life that was just kind of like the epiphany that changed the way you looked at things? So I had to go back 30 years for this.
Okay.
So 30 years ago, I started working in industry, and I'm doing ECO changes in generic CAD 6.
Right.
And 5 years later, I have a couple patents for the company. I'm the go-to 3D guy, but you don't get there by magic. You know, it takes a lot of mentors. And so luckily I had this guy, John Sullivan. He came in to ask me about this project, and he said, hey, can you help me with this? And I'm just going to play the video again. And so what it was, we had a insulator with a slot in it, and we needed to put a conductive centerpiece in it. And I'm like, oh yeah, piece of cake, you know, we'll offset it, throw it in there, and there we go. Well, John comes in, he looks over my shoulder, and he's like, okay, how are we going to build that? I'm like, well, it didn't really seem that unusual to me. You know, it's like, well, it's just a rounded piece. He's like, well, if it was me, and John was a great machinist. And so he said, well, what I'd do is I would turn it, it'd be a turn part, and then I'd mill the 2 flats.
Right.
And I'm like, oh my God, that's brilliant. It fills the space. It's an easy to make part. And so now I look at everything. It's like, okay, how is this going to get built? And then over the years, I take a look at it from the maker standpoint. And it's like, okay, how is, you know, this is how is somebody else going to build this, but I want to know how I'm going to build it. And you've got an awesome shop. You got a lot of cool tools. If I need to cut a disc out of plywood, I'm probably going to go, well, I'm going to need a jigsaw.
Right.
Or I go down to my makerspace because they have a shop bot. So that really gets me into the mindset. And that's what triggered with the tombstone.
Right.
So, and I did throw in a bunch of SolidWorks tips here that I'm just going to hit really quick because I flew through them. And it's just little stuff that, hey guys, I like working with slots because you can right click on an edge, select tangency, boom, the whole thing's selected. S key pop up, I get the offset command, key it in, right click, reverse direction, right click. Okay. S key shortcut, I draw a circle, pop in my circle. One of my favorite ones is coming up here. This came from another John Matrician, my brother from another mother. The power cut, you know, the cut tool. God, I lost my place. Power trim.
Power trim.
John's a master of this. And so I was in the power trim tool the whole time. And if you hold down shift, it will extend the lines.
Very cool.
I was always right click, toggle back and forth. And John's like, just hold down shift. And so then at the very end there, I just, I put a lot of my tools that I use to exit sketches into my S key pop-up. So extrude, sheet metal, a lot of those. I did that, double click on the face. It goes up to surface. Where my mouse was, I hit tab, boom, it hides that. So back to this.
Oh, yeah.
I'm looking at this going, I've got a flat piece here and I'm going to try to weld it to a tube.
Yeah.
Do not have mad welding skills.
Sure.
I said 25 feet away from a great welder. Hey, Sean. It would still require fixturing and we would need something to hold it straight. And if it was off at all, that chain would not be in line. That would be a huge problem.
Sure.
And there's no adjustment. So it's got to be dead on. So I said, okay, this is all on the 3D lean board. Hey, what if we did something like this? We could pick up the existing motor mounts. We can mount it vertically. We're throwing some braces, call it good. So this is what we affectionately refer to as the boat anchor now.
Yes, it's a great name.
Because this was the original prototype. If you look in the top view, I put my slots perpendicular to the slots that were on the existing mount. So that gave us side to side and front and back adjustment. So we've got all sorts of adjustment. Originally, I had to design this in like 7-gauge steel.
Nice and beefy.
Well, it's strong.
Just in case.
I remember the first design.
Yeah. It was 7-gauge. But to get it to you fast, the department I'm in, QRM, we do a lot of it's quick response manufacturing. We make stuff happen.
Yeah.
So we cut a lot of 1/4-inch hot rolled pickled oil. We do it for our fixtures, stuff like that. So I said, hey, let's just throw this into a nest. Boom, we'll get you some parts.
Sure.
So this is an example. I showed you like some good stuff. This is one of those learn from bad examples.
Yeah.
Just because it's cool doesn't mean you should do it. You should have learned that by high school. So that one, I'm going to play it again just so I can talk over it really quick. I did a single part with multiple bends. Well, you're going to have to put in special tooling for those small ends. And then when you go to bend that bottom up, you're going to have to try to fit around those tabs.
Mm-hmm.
So the best thing about this is because I made it with a sheet metal part, I have these top 10 rows here. And I can look at my bounding box area, which is the smallest sheet that we can cut that part out of. And then the bounding box area blank. And that's actually what we're cutting. There's a big difference. So I've got a lot of wasted material. We can nest things pretty well, but yeah, that's a bad way to do it. Don't do it that way. So this is how I actually did it. It was just a one simple bend, 2 pieces. We slap them together, weld them on. They don't take up much space at all when we cut it. So I'm going to go to, I'm not going to go to you yet because that was just a prototype.
I know. Did I see the zip ties?
Oh,
did I see zip ties?
This was the cringe part for me, and we had to make it work. I sent the part up, and then they had a build day.
Sure. But listen, guys, you got to understand something. That's not just a normal zip tie. That's a zip tie chained to another zip tie. That's a double zip tie. You don't just do that. You got to be qualified.
That's space grade.
And that strap that's off a trail camera, that I had laying around, and we cinched that puppy down, and it worked.
Well,
it got us by.
I'm really impressed that it stayed on because now that I've ridden this, I know how they just tear you around, and you're basically just holding on for your life. And for a couple of zip ties and some nylon to hold it in place, lovely. But we can do better. So as soon as I saw this, I said, okay, we got to you've got the controller stuck to the top of the battery box. We need that right next to the motor. So let's make something that has all of it together. And so while you guys were modeling the battery box and all the stuff, you threw all this stuff up on the 3D lean board for me. I was able to pull the stuff that I needed and throw this up on the lean board and say, hey guys, what do you think about this?
I gave you the thumbs up.
Yes.
Right there.
Now we're on track. This is a little bit different from what we actually did, but this was the ballpark. This was what I was after. I wanted something nice, compact,
So clean. So
we
simple.
pick up the existing.
Perfect. Love it.
And so I'm just going to touch on the design really quick. Just quick square. I always like to show this during the when I would teach essentials, because when you fully dimension it, it's still blue. And it's like, well, wait a minute, why is it still blue? Well, it's not located in space. So that's why I would start the essentials class. I would sketch over here, and then I would drag it back to the origin and say, okay, now we've located it. It's fully defined. And then a sheet metal trick that I like to use is I'll draw the box, and then you just change one of the lines to construction, and you get the nice U shape. And so now sheet metal cut or sheet metal tool on my pop-up, right click, mid plane,
That's awesome.
key in value. So
I love sheet metal.
I'm a huge fan.
I'm a huge fan being a simulation engineer.
And so,
and you'll see why.
Yeah.
You'll see why.
And this is one of the lessons that I learned the hard way as well. And I always told people when I taught the sheet metal class, I can teach you how to use the tools, but to really learn sheet metal, you have to talk to the people that run the machines.
Right.
Because you bring them into the conversation. You don't send something out there because something like this, they're going to like scream at you. And they have all kinds of special names for me at work.
Perfect.
But I ask them about it now. And this is something that when you go to form it, there's a really good chance that when you make that second bend, it's going to hit the machine.
Right.
Because anytime you have a narrow U that's really deep, you have that problem. So here's what I did to remedy that. I just dip into the sketch. I want to keep all that geometry the way I have it, but I'm using the split entity feature, and I'm just splitting the line. So I still have all my geometry, but now I have two separate lines. Make those equal, throw a dimension on them. That covers it. And what this does is it gives me an L with a little bit of a lip, and then I can put the other piece on here like this, and that's going to complete the design. The last little bit there, you see, this is one of those things that always drives me nuts. I know it doesn't drive you nuts, but I saw blue, so I had to define it.
Yeah, I never define. I don't define any of my sketches. I seriously, I think it's.
Oh, I know.
It's unlucky to do, you know. So I just don't define things.
I'm just going to give you grief
That's how I
about
live
that.
my life. Right. Undefined.
That's right.
Breaking the law. Breaking the law.
And so this is what we ended up with. This was what we did. I just rolling back through this. This was the original design. Throw on some tabs, pop the holes, pop the hole for the motor mount, throw on some fillets, throw in the slots. Bam, there's that. Come back to this. Like to use display states to just kind of show when I'm toggling between things. So this shows us the motor side or the battery pack side. And toggle back. This is the motor side. You can see how we got the controller in there. We raised them up off the floor because we talked about wanting to run the wires underneath everything.
Always an issue.
Hide wires.
Wire clearance, because you always want to build everything tight and neat.
Yep.
But you always have these wires and cables that just take up room. We would call it the squirrel's nest.
Yes.
Where's the squirrel's nest going to go? Because you always have to have room for it.
And the lean board saved this because we had one of these up there and somebody's like, oh, hey, that motor is a little bit off in the size. So I had to open it up a little bit, and I saw it on the lean board, and that's what caused me to fix it.
I saw it in your model. I'm like, that motor just looks a little shorter than what we have in real life. Because like in real life, it was an inch.
It was
so you
sticking out.
added that extra inch, or else it would not have fit.
And so now we have something, but now comes the question. I did this out of 10 gauge. Is this going to be strong enough? Because, I mean, we did the boat anchor. That was 1/4 inch. Shreyas, you need to give us some sanity here. Let us know if we did okay.
Yep. So what I did was, obviously, this is a good start, right? This is a good start. I think we have a solid design right here. And I'm really glad that we went away from that double zip tie thing.
Those are hard to analyze.
Yeah. First
I
thing,
put the lip on the top there to make that stronger. Hopefully that'll help.
yes.
This
First thing
entire
is-
world runs on zip ties. Okay.
Well, we wanted our executives to write this, right? Drift on this thing.
Uh.
So it would have been really hard to justify having zip ties on it,
Sure.
right? All right, so this was a good start. Todd did fantastic in closing all the three components on it, right? You have the electric motor, you have the converter, you have the battery pack as well. So what I went ahead and did was ran some simulations on this to just try and understand the real world performance of this. Again, this is kind of a fairly evolved design based on Todd's experience, and what I wanted to do was put it into some real world scenarios using SolidWorks simulation
with our super torquey motor.
With the super torquey motor from Bowhead, right? So okay, so first things first. One important thing when setting up the study for me was to make sure I converted all the toolbox feature you had, right? Because hey, look, I mean, I can in this particular design, right? There's what 6 bolts. I can probably go ahead and model them for simulation, but imagine having like hundreds of bolts, right? I don't want to spend hours and days just defining my bolts.
Do it for me.
Well, I wish it was fast, but that's the thing, right? Being integrated with SolidWorks CAD, I have the leverage to understand my toolbox features, right? But that's not only it, right? It actually understands the background behind those bolts. It understands its physical properties. It understands dimensions, diameter, shank length, and then also it understands the bolts from a structural or mechanical point of view, right? What's the strength? What's the factor of safety? What's the material on it as well? So that's a pretty powerful feature. All I have to do is just make sure I check that box when setting up the study, and boom, all the bolts are in it. Now, you're probably wondering, hey, what if? I know, Jason, you mentioned a couple of bolts were not performing to its optimum. Maybe we had to change it. What if I had to change my bolt properties? Well, I can always go ahead and edit them, right? That's an option. So I don't have to worry about sticking with the same old bolt in my simulation, even though I have extracted, pretty much all the details from the toolbox feature itself.
Because we did shear some motor mount bolts,
That's
the
right.
bolts at the four at the bottom that go to the frame from the torque of the motor. It sheared a couple bolts.
So you can, obviously you can specify or override the properties, or put it that way. And then obviously I want to quickly check my materials right before I go ahead and, here's another interesting feature I want to talk about. Sheet metal. I told you I love sheet metal, right? So when you define something using a sheet metal feature, simulation understands it, right? Now, what it does by default is it automatically sets up or creates a mid surface and does a shell mesh, which is in scenarios like this and models like this, much more computationally efficient. But what if I don't want to treat it as a shell, right? You can always say just treat it as a solid, and it's much more easier from a setup point of view.
Gotcha. Okay.
So you have that option as well. But the point I'm trying to make is simulation tool is smart enough, is intelligent enough to read the features from your CAD.
To recognize it.
Yeah. All right. So I'm going to talk a little bit about some advanced things you can specify as well. Not that we have to, it kind of bonds things together by default. But here what I'm trying to do is, so you have two pieces of the sheet metals, right? And then you have 4 bolts, 2 on each side, front and back, joining these 2 plates, these 2 sheet metal pieces. Together. So you obviously have the bolts, but then in addition, if you want to specify contact interactions between these two pieces, you can customize them as well. For example, you can specify what's the friction between these 2 pieces, right? All you have to do is make sure you select those set of pairs and then specify what kind of friction might be there as things start to move along, which we'll see in just a bit. All right. Where are we at? Okay, so that's pretty much it in terms of setup. I'm gonna apply some boundary conditions, and then we'll run.
How it's gonna lock down.
Yeah, exactly. So the first thing I'm doing here is basically applying fixed boundary conditions. So I know you mentioned about the slots at the bottom. And that's really good, right? In terms of flexibility, remember the goal here we're trying to achieve is reduce compliance, minimize compliance. This is going to house the motor, right?
Yeah.
Any misalignment, the chain's going to pop off.
Oh, yeah.
Right. Or it may even snap, right? So we certainly don't want that. So we're trying to minimize any displacement. So, okay, so I applied some fixtures. Now, the other thing I'm going to also specify here is now these components, right? You have the electric motor, you have the battery pack. Am I missing anything?
The controller.
The controller, yeah,
Yes.
yeah. So there's some weight associated, there's some mass associated with these components
Sure.
as well, right? So in a static state, I basically specified, okay, this is the location where my electric motor is going to be mounted. So you have the 4 poles. So I'm specifying the XYZ coordinates of the center of mass, right? And then basically applying some static load to kind of assume it being a mass at that center of mass location for the electric motor. I do the same for the battery pack, which is
pretty heavy.
Pretty heavy, yeah. And the good thing about this is it actually fastens the battery pack in a much more modular way, right? So you can kind of replace the battery pack as well, right?
Yep.
And put it back on, which I thought was a good
Hot swap.
design. Definitely better than the zip
yeah.
ties, right? Definitely better
Yeah.
than the zip ties.
You got to cut them.
All right. So yeah, that's that. So I went ahead and applied, these static forces to kind of assume, okay, those were mass. Now, torque. We have to talk about torque.
It's
right?
crazy.
I mean, I had a chance to, drift this around. This thing is powerful, right? And it can throw you off, right, if you're not used to such power. So we wanted to make sure that the mount where we were designing is powerful enough, is stable enough, is robust enough to kind of handle such high torque scenarios. So basically, we're applying some torque to the locations where the electric motor actually goes. All right, enough of the setup. Let's go ahead and mesh this and run the study, right? I'm going to skip to the part where we have some results. Okay, what are we looking at here? Stress plot. So probably not the most accurate way of looking at it. So I'm going to do some customizations on this one. I know my yield stress is around 220 megapascals. So we'll kind of
That's
play
a mean
around.
stress.
What's that?
That's a mean stress. That's a lot.
Yeah. So we have some, chart customization option. I can play around with the legend I see here on the left-hand side. I can, customize it. Say, okay, my maximum stress is going to be 250. That's what I want to see. And then we can see where our yield strength is at. So fairly.
Red is bad.
Red is bad, but not necessarily always, right?
Yeah.
Red's bad if it's
Like your
stress.
shirt. Yeah. Your shirt red.
No, this is good. This is really good, right? Anyway, so what you see here is basically the stress plot and the locations where we're kind of mounting the bolts.
It's red.
It's probably singularities. We may, we can come to that later, but yeah, that's basically the locations where we saw a lot
Attach
of
it.
yeah, saw a lot of stresses, and even with factor of safety as well, right? It kind of replicates well or goes well with the stress plot we saw. But what we're really concerned about is the compliance issues, right? And even before that, let's kind of talk a little bit about the bolts, right?
Okay.
The bolts that we got from design or the toolbox, right? The bolts simulation understands from the toolbox. It's not just that it only understands it, considers it in simulation, but it actually gives you some meaningful results when you simulate it as well, right? For example, I can look at any bolt. I can see, okay, what's the shear forces in it? I can see what's the axial forces in that bolt. I can see what's the bending moment in it, right? So if we feel like we're getting close to its limit, we can obviously opt for a better grade bolt, right? So you can basically get a lot from these simulations, especially if you're dealing with fasteners and
Many fasteners too. Yeah.
connections. All right. The most important thing is displacement. I was
That's
talking
what
about.
I'm worried about.
Yes. Yeah. So we want to keep the compliance, or we want to keep displacement as low as possible. This thing has a lot of power, and any sort of misalignment between the driving and the driven sprocket is just going to be.
That's what I was afraid of. Like if that motor torqued and it twisted that and that bowed, because I mean I put that lip on the top,
Yeah.
to stiffen it a little bit, but if it was enough to twist that sprocket out, you're going to throw a chain.
Yeah, that's right. And you can see.
Might
So
have
again, it happened.
several times.
Who
yeah.
did that?
There was Sal, Chinlu, Andy, me, Jordan, you.
I think
you did it once. Todd, you did it once, right?
All right. So,
like I said, a lot of torque. Right?
Yeah. So again, red is bad in this case. Red is basically where the maximum displacement is. All I'm doing is selecting that line, that dotted entity, and plotting my displacements across that line. And you see how it goes from, and maybe I can use my laser pointer here real quick. Let's see, or maybe not. Oh, I can. There we go. 1.3 maximum displacement. It may not sound like it's too big of a deal, but I mean, 1.3 is high enough to pop that chain out real quick. So I guess what we want
It's
to do.
enough. We want to look at it.
Yeah. I think what we want to do is probably have some kind, because you see on the left-hand side, it's all red, right? It's high displacement, right about, here and about this sheet metal, and not so much on the other side. We probably want to do some kind of mechanism, some kind of load transferring sheet metal
it all
up at the
together.
top.
Pretty
Yeah.
box.
And I'll leave it up to you, Todd, on how you want to. And I think you're probably already ahead of the game, right? I see some bows. I'm sure you're up to something.
Yeah.
So what are you up to?
So I didn't know if we would need it or not. I kind of like the idea of leaving the top open so you can see all the awesomeness inside. But
And it's also easier to kind of service the components.
get in and work
right?
on it.
Yeah.
But if we need to tie that together, we can. And what I ended up doing was just a simple X that covered the top. And this is just a short video of me drawing it. And this was just more fun because I know my bolt hole locations. So what I'm doing is I'm drawing a rectangle. The corners are going to be the bolt holes. And then I really like working with slots because they're fun and easy to draw and easy to connect. So I throw in a slot, throw a couple dimensions on it, and then I grab it,
Interesting.
mirror it over.
Yeah, I only use slots to make holes.
Yeah.
You do them to actually draw
designs.
That's awesome.
Would you have
That's
done
cool.
dimensions, Jason, or not?
No.
No.
Yeah, of course I would have. I would have had to have with the 4 holes. Yeah. gotta hit the target. Yeah.
And the thing is, if you do it smart, because I did a bunch of mirroring, and then I did the slot from center to center, so that gives me the end locations. As far as the width, I just make it equal to the other one, mirror that over.
I would have drawn an X, then offset it on both sides, but then it wouldn't have been.
Yes.
I would have had to put in fillets at the end that I'd just be guessing at.
Do you know how I would have done it?
That's
I would have called Todd.
Call time. It's a good idea.
That's as far as my design.
So
knowledge goes.
there's just a bunch of little oddball, and I'll play this again because it's a quick one, but there's a lot of little oddball tricks that I like to do as I'm sketching that just make life easier. The rectangle, while it was all highlighted, the keyboard shortcut for convert to construction, and then I swoop the middle, convert to construction. I drew the slot, mirrored both of them, connected the slot between the two, and now I'm just doing whole wizard to pop them in. But do you ever play with 3D? As far as instant 3D, I love it. This is one of my favorite tools just to kind of see how something's going to behave if I change dimensions. And the thing about that, this is something that I run into a lot of people that don't know about this. When you drag it, you see the ruler. Well, pay attention to your cursor. I can't say this enough. There's so much that happens at your cursor. So when you're dragging the blueberry, the blue dot on the end to change that dimension, if you're further away from the ruler, you have finer detail. So you get down to thousandths. And then when you get closer to it, you're snapping to the even numbers. And that's how I ended up with even numbers. I just bring it back and I snap. And it's just goofy little stuff, but bam, there we go.
It's great.
So, and there it is.
Real life.
So, and it kind of looks like an X, like Slug Me 10.
Ooh.
Oh,
Slug Me 10. Now, do we have any good ideas for Slug Me 10?
We've talked about a few things, but we really need to throw it to the chat and see what people think. It's like, what do you want to see us build?
Hey, what do you guys want us to make next year?
Because we've only got a year to think
Must
about
be
it.
approved by Eric Beatty.
So, we've kind of seen how the motor mount goes together, and you really wanted to see like how we made it. So
Always. I
we've
love
got a
manufacturing.
video, and I gotta say, I work with an amazing team, and I was like, okay, well, guys, when you make this, can you just shoot some little videos,
right?
So we can show them how it's done. So, in the video, you see him doing the nesting. You'll see him take it to the laser, and the laser doing the cutting, popping the part out of the laser. You see our bending software that we check it out, and that's usually the fail-safe Todd thing, where it's like, hey, Bill, can you run this and make sure that it'll bend? Because he can do it on the computer without smashing the machine. And that's
But I did run some simulations
Yes.
on it as well, right? I did run some simulations on your new design.
Yes. So
Right.
what we're going to do is we'll finish the video, like let people see like how it's being made. And as soon as that wraps, we're going to see the post results. I
do
got
it.
ahead of myself because I was really excited about bragging about what we do.
Yeah, no doubt.
And, because we can do a little bit of everything. And so we see the sheet, the computer for the forming to make sure that everything's good. We see the guy actually doing the forming. It goes over to powder. They wash the parts, they powder the parts, and then pull them out and package them. So it was like the full thing. Now, for the everyday user, there's a ton of companies out there that you could send DXFs to, and they can cut it for you and send it back. Look them up. I think we're going to start working with some of them. SolidWorks is, but there's a lot of great reputable companies out there. I just happen to have all this stuff at my hands. It's like right there. So let's go ahead and go to you doing the analysis.
Yeah, on the
Because
on
I
the new
wanted to
part,
see
right?
if this made a difference.
That's right. Yeah, that's what I'm excited. I was excited about as well.
Because I just made it look cool.
Yeah. All right, let's see.
Let's see it.
So, well, the first things first, right? I mean, as soon as you have a new design, in this case, it's just a new feature that you kind of added to it, right? But as soon as your design change, it's not like you have to start from scratch when it comes to simulation, right? Because imagine like spending, in this case, we probably spend like 30 minutes, but imagine a big simulation, right? You don't want to spend days and weeks just working on rebuilding the model for simulation. All you want to do is, the ideal state here would be to just kind of use what you already have in terms of your existing setup, and then update the changes in your design, which in this case, update the X mount that you built, right? And incorporate it into a new study so that we can also compare it side by side with our previous iterations.
Right.
That's exactly what I did, right? Copied the study, made some changes in terms of setup. And obviously those bolts as well, the 4 bolts that now you have
are now part of the
X
calculation.
Are part of the calculation. You guessed it right. And that's it. That's all you have to do, really. You don't have to spend any additional amount of time.
You're not starting over.
Not
You're just
starting
adding
over.
on.
Yep. And this is the most important thing when it comes to SolidWorks simulation. It's integration with CAD. You saw how it understands, how it's smart, and how it's intelligent enough to understand your design features. That's just amazing. Makes the life of simulation engineer much more easy, right? All right, let's quickly take a look at some results. I know that's what
Red is still bad, right?
That's right, Jason. Red's still bad, but it's
bad.
It's less bad this time around. That's a good way to put it. Thanks, Todd. So, and we'll look at some numbers as well. But right off the bat, what you can see is initially we had red on the other end or the back end of one of the sheet metal
Because it
pieces.
was opposite the motor.
It was opposite of the motor. Oh well, on the side.
It was on
of
the same side,
same side,
but
on
at the far end.
Far end, exactly. But this time around, with the X mount, right, the forces kind of get distributed from one sheet metal to the other sheet metal fairly efficiently, I would say. But nonetheless, I mean, you still have red.
Yeah.
On the other side of the mount, right? And if you remember or recall the magnitude of displacement, max displacement from our previous iteration, it was around 1.3 millimeters.
Yeah.
And right now, what we have is around about, and let me see if I can highlight it for you. The max displacement we have is 0.7 millimeter, which is less than a millimeter, right?
50%
Now, I
better.
would, yeah, if I did my numbers right, it's
55.
probably 45-ish, I would
45.
say.
I knew
45.
I knew
yeah.
there was a 5 in there.
Yeah. So relatively much better. I mean, again, it
Yeah.
may not look like a big thing, but still,
It's
I mean, from a
deflecting that much less.
Yes, yes.
Keep
So
the
that's-
chain on.
Yes. So that's basically
This is
how we
good.
went about our design and how it evolved. We used, we integrated simulation with, what we wanted to design, and eventually we ended up with this, which is a much more robust design in our opinion.
Okay.
Again,
So-
we didn't want our executives to write this thing with
Get your approval. then
couple
to
of
rock and roll.
That's right.
Yeah.
There we
Well,
go.
and the great thing about this was when we had it done, we took care of it from start to finish. We sent Jason powder coated parts. They were ready to bolt on. Now, the frame we got was raw.
Yeah.
And luckily you've got some connections for the paint.
Powder coat. Yep.
Powder coat, yes. And one of the things that one of our past Slug Me presenters, Artem, did, he does CAD Plus, which is an add-in for SolidWorks. Very cool program, but it's just gone so far beyond, because a lot of times people are after the paint coverage, to figure out the costing, how much is this going to cost in paint? How much are we throwing down? He's added a paint estimator to his CAD Plus tool.
That's cool.
And
That's
it's
awesome,
in
yeah.
experimental right now, but we've got a video of him showing it off, and it's very, very cool. It's really neat. So we're going to show the video. We're going to run over. We're going to look at the trike
Oh, let's do that.
because we really want to see that. But let's let that play and let's go check out
Yeah,
the
let's
trike.
do it.
Let's
Hello, this is Artyom from Xerial, and I'm excited to be a part of SlugMe 2024. For this event, I was tasked with finding a way to calculate the paintable area of a model. Doing this manually would be quite complex. Typically, you might take a simple approach and use the Mass Properties tool in SolidWorks to find the total surface area. In this example, the surface area is about 2400 square inches. However, as you would expect, this is not an optimal solution when you need the more precise calculations, like excluding the internal faces that won't be painted. This is where SolidWorks API and partner products can be incredibly helpful. Today, I want to show you a feature from CAD Plus toolset, developed by Xerial, a SolidWorks solution partner product. CAD Plus toolset offers many features to streamline your SolidWorks workflows, including managing custom properties, generating reports, automating drawings, handling bill of materials, and exporting data. For this demo, I will be using the experimental paint area calculation module. Let me start by running the paint area tool. First, I will use the default settings and hit recalculate. The tool will automatically detect and exclude internal cavity faces from the calculation. As you can see, it found an optimal paint area of around 2100 square inches, which is approximately 87% of the total surface area. The areas to be painted are highlighted in red. Let me turn off the model transparency so it's easier to see. You will notice that some of the internal faces are still included, so we'll try to improve this result. One feature we can use is the ability to add caps to certain faces. This helps close off openings and refine the calculation. To do this, we activate the selection box and select the faces we want to cap, such as these planar faces. The tool will automatically cap them, improving our result. After selecting the faces, I will click Recalculate again. Now the paintable area has improved further, covering about 67% of the total surface area. We have excluded more cavity facet, but it's still not perfect. Another powerful feature of this tool is the ability to cast rays onto the model, simulating the paint spray. The rays help detect which surfaces would be hit during the painting process. There are a couple of options here for specifying ray direction, rectangular and spherical. I will select the spherical option and use the default parameters. After running the calculation, we get a performance warning due to the large number of rays. I will reduce the ray density by decreasing the tolerance and increasing the distance between the rays, resulting in about 16,000 rays. The calculation should take only a couple of seconds. To further refine the results, we can focus only on external faces by specifying a threshold. The threshold represents the percentage of a face hit by the rays in relation to its total area. If the percentage exceeds the threshold, that face will be considered paintable. Let's set the threshold to approximately 50% and recalculate. You can see that some faces were excluded. Now I will lower the threshold to 10% and recalculate again. This gives us a near perfect result, with all internal faces correctly excluded from the paintable area. The painted faces are now clearly visible in red, while the internal faces retain their original gray color. Calculation result suggests that around 57% of the total surface area will be covered with paint. Finally, we can save this data to a custom property for further use in calculating the amount of paint required. Thank you. Please do not hesitate to contact me if you have any questions.
Internet?
Oh, yeah.
Hi. What's going on, Internet? Welcome back to Real Life. We're here with Luke and Todd. Todd, what about this paint thing? You want to say something about that?
Nope. I was just going to say thanks again to Artem for contributing to another Slug Me.
Heck yeah. So yeah, this is it, Real Life. This is the Todd Blackshear motor mount. It's also known as the Mega Mount. And Todd, you showed us in virtual space, but now you can show us in real life.
Well, cross brace that we needed because it was flexing. We were able to tuck in the motor. Here's the controller. All the wires are going underneath.
Squirrel's nest.
And you can't really see it, but there's bolts in the bottom that we picked up the existing mounts on the frame. And then, we're just putting this magic piece on. Made the whole thing a lot stronger. We've got the mounts for the battery.
Battery time. Need the juice. 80 cell straight from Bowhead. Show.
You got to show that.
This is the coolest thing. It's in a Pelican case, watertight. Isn't that awesome? I was really impressed with it. It's very heavy, very functional, hot swappable.
Just drop it in.
Just plug this in, see, and then you can sometimes hear a little snap. Oh, that's a good snap. Hear that snap sound?
And here's the fun part. The battery pack's pretty heavy.
Yeah.
Look, we got the.
Yeah.
How did that compare?
I mean, it's about the same weight.
So this is prototype 1.
Yeah.
This was prototype, mount 1. It didn't get the title Mega Mount yet. Okay.
Because it didn't do everything.
Right. It held onto the motor, which was good. And it got a little twisty along the way, but
it was fine.
Extremely heavy. It doubles as a boat anchor.
Yeah. It was just to check the form, fit, and function.
Yep.
But because all I knew this whole time was I was just throwing stuff in boxes and sending it to you.
Perfect.
Throw stuff in boxes, send it to you.
Yeah.
Look for pictures, jump on the 3D lean board, see what was going on.
Yeah.
But I'm in the dark here. I'm like, please work.
Yeah. And I was in real life in my garage, and parts were showing up left and right, and I'm unboxing things, putting things together, and triple checking measurements and updating the lean board so you could see the new numbers. But we had a lot of obstacles to overcome, and I think the first one was, what do we do with the chain and sprocket? I was stuck on, I know Todd's got the motor mount cooking, but how are we going to get this energy from the motor to that axle so we can spin really fast out of control, and it was all about the chain. So Dan Wagner, he ordered like 3 different chain setups, and what we ended up going with was a number 35 chain.
Yep.
Okay. And it fit the best. It wasn't too big. It wasn't too small. But how we got there was kind of a funny story.
It was hilarious.
Well, at first, we had this giant sprocket, and Sal, he goes, guys, I did some calculations here, and according to these numbers, you're going to go about 5 miles an hour. Is that what you want to do? I'm like, no,
It's made for a gas motor.
no, that's not going to work. Like 5 miles an hour is not okay ever. Like I walk faster than 5 miles an hour. So he figured out that the best ratio would be just pretty much 1-to-1. So the rear sprocket is the same size as the front sprocket, and go from there. But the thing is like this is a lot of custom parts from the go-kart industry, the dirt bike industry, the bicycle industry, like all these different worlds, bicycles coming together. And we had everything except for this one sprocket right here. We had to put it on my CNC machine and mill it out so it would take the shaft of the motor, because everything was coming together except for that. So when Chin Lu and Sal and Dan were at my house the first time when this was completely raw and we're like trying to figure this out, that's what we ended up doing. We put it on my mill and just blasted like a quick hole and just open it up just a tiny bit, and it slid right on. So that's when we had that moment of like, this is gonna work. This is gonna work.
I just remember being deeply jealous of all the stories of you guys hanging, and I'm sat there on WhatsApp going, "Oh, I'm missing all
So
of the
much.
fun, so much fun."
Yeah.
I was looking at him. I'm like, they really need a biker there.
Yeah, exactly.
Talking about the chain, I'm like, I have a chain breaker.
Oh, the first time we were cutting the chain to fit, I didn't have a chain breaker, so we used my cutoff wheel. And I'll never forget like Sal's face when I first fired it up, and the cutoff wheel was like, I'm like slap. I'm like, he took a step back, and I was like, oh, I better tighten that, buddy. I better tighten her up. So yeah, we got it done though. We got the chain on there to fit. It took a couple iterations, but the first time we fired it up with the zip ties and the original mount, to me, I was like, I'm a big guy, and I'm like, is this gonna spin me around like a rag doll out of control? Or is this not going to have enough juice? Because I was doubting the size of the motor. Because when you look at
It's tiny.
it is so small and compact, that motor. And I'm like, I don't know. Is this really 600 RPMs, guys? Like, is it
And
really
had you-
3,000 watts?
Had you
Yes.
dialed it in by that point? Like,
Oh,
or is it still 100%?
It
power?
came amped, right?
It came amped, ready
Yeah.
to go. Wow.
So when we first fired it up and it threw me around, I was like, we're on to something. This is going to work. And then it might have been the second visit that the guys came back to my shop. And I was like, okay, now we just got to know what the top speed is. Okay. So where I live out in the country, the road's empty and it's slightly uphill. And I didn't have a speedometer, I'm like, I don't have a radar gun, I don't have that yet. So I talked Sal into following me in his Tesla. And I'm like, you'll be fine. Just try to keep up with me and tell me what your speedometer says. And he was like, okay. And going slightly uphill with me on this, we got up to 33 miles per hour, which I was thrilled with. So, yeah.
It feels
Scottie
a lot
Pippen,
faster when you're
33.
that low to the ground, though.
Yeah.
Like, it doesn't sound like a lot, but when you're like inches away from
When you're
ground,
in the
it's
ground,
horrifying.
inches, like this is up on the wood block, I mean, it is scraping the ground, literally. So,
And you're scrunched up. And
yeah. And
it's,
you kind of got to look through the handlebar to see where you're going.
Yeah.
But fun. And that's what it's all about.
You're rarely going in a straight line anyway, so
Yeah.
the direct forward vision is largely irrelevant.
Yes. But there was a lot of things to figure out. And along the way, we realized that the safest thing to do is what Dan calls a tech check. So every once in a while, we would yell, tech check! Because like once you get on it and you're going, Andy and Jordan were probably the most dangerous because like they were just like, we're out in real life. There's no keyboard. What do we do? What do we do? And they would just like freak out and hammer it and just spin around. And I'm like, Dan, we got to do something. We got tech check. And that tech check meant stop. We pick it up. We check all the bolts, make sure the wheel's still on. And then we move forward from there. Yeah.
Nice.
Because we have to be safety.
Yeah.
We do have
Safety second.
some rules to follow. Yeah.
I was amazed by how safety conscious you were with it because I was
you
like,
gotta be.
Jason, he's a crazy guy. Everything's exciting. He's like, guys, we need to do a check. You need to get in, take the keys. I was
Shut
like,
it off!
oh my God, this is not the Jason I remember.
There's a
No.
sequence of
There's
events.
there's another Jason that you guys don't know.
Yeah. When this thing is hot, and that means that it's connected, the key is on, that throttle, you touch that throttle, and it's all go. It just wants to rip, and these tires come off the hook, and you'll go for a ride if you're not paying attention. So if you have your foot underneath it or something like that, there was a couple of gentlemen that grabbed the brake and the throttle at the same time. Also known as whiskey throttle, I think. And what was weird about it is it was the first time these things moved together outside of my garage, and it was Dan and Sal, and they both did it on trikes at the same time. So it's very weird. Like in my driveway, it's like this loose gravel, and it's like these burnout like 2 tire tracks. And then there's a skid track in the front where they grab the brake and the throttle at the same time. It's like, it's interesting, but you can do that on this.
Yeah, nice.
Highly recommended, actually. Yeah, so all these parts are coming together, and it's just really cool to see it develop.
Yeah, and I think, because that's pretty much the story of the motor mount. I think what we're going to do now is we're going to go back to the front desk, and Sal and Chen Lu are going to talk about the parts that they did for this and that you assigned to them.
Cool.
Hey everybody, welcome back to the desk. I'm here with Eric and Chen Lu, and we're going to talk to you about the Gut Guard. How you doing, guys?
Good.
Super
Excited.
duper.
Now, actually, Gut Guard, you coined that term, didn't you? Because you love alliteration.
Oh, totally. I mean, folks are calling it the gut protector. That was just too many syllables.
That was my idea. So
GG, Gut Guard, you're good to go.
yeah. Oh, hey. So we got a lot to show you here. I want to actually first start by sort of setting the stage. Once we got that motor mounted, as you can imagine, we were thrilled to get on it and see what this thing can do. And as you heard the guys just say, it rips. And as you're sitting there with your feet spread apart and your hands all up, you're at the mercy of what the road might kick up from that front tire right into your gut. So we knew we had to build a sort of safety protection in there. And we got started with the design that Andy actually came up with.
Yeah. So you can actually see it's Andy, who is like the king of patterns, and it is a beautiful Voronoi pattern. It's something that was carried over from another design that he did with us on our next make, but we'll talk a bit about that. I wanted to actually show you an example that I have here. We had a few made, but one of the main design concerns we had when we first looked at the pattern is it is full of holes. So if we had stuck with just the
Not much
design
guarding your
itself-
guts there, Pebbles come in all sizes.
Yep, it goes straight for the soft spots. So what we thought would be nice is actually sandwiching
There we go.
something more protective, like a piece of acrylic. Thank you.
Right on.
And because we had this idea of embellishing the design, we wanted to leave a little hexagon shape to, bring in that traditional SolidWorks cube. And there's some cool things we've done with it. We'll show you in the actual build, but you're able to engrave a nice piece of acrylic and light it up. So that's going to be a fun little showcase.
I've seen it and it looks awesome.
In some of these builds, I think that the thing that I doubted the most when I first looked at this design was the ability to cut these really, really small, intricate holes and still keep the integrity of the material.
Because you tried doing this on your laser and you were like scorching through, weren't you? and
Yeah,
everything?
depending on acrylic or wood, we were really coming down to just the heat overcoming the material.
Well,
So-
you don't get that with a water jet.
Exactly.
There's no
So
heat.
first thing we thought of is, what if we made this out of metal? And who do we know who actually knows how to do something about metal and water jet it? So
I think we have a video of that in a second. But for those of you who are interested in the Voronoi pattern, that's the geometry that you're seeing there. It's something that occurs in nature everywhere. Again, Andy schooled us on this recently. It's a really cool thing that nature just creates.
yeah, like the patterns on the giraffe's body.
Yeah, and in the recent past, we had a chance to work with Andy on a passion project of his own. He's an avid record collector, and he built this record cabinet. We helped him in our shop to do it. It's actually something, if you want to see more about that and see how that project came together, you can check out the RNX Make channel.
Yeah, it's one of the projects that I actually love the scraps, because anything that didn't make the cut, we got to use for something else. So there'll be a lot of projects we're going to be
In
using
fact,
for the scraps.
is it too early to call dibs on these copper ones? Because I would love to turn them into something at home.
Oh, I have ideas
Yeah.
already, like a floor lamp, all sorts of cool stuff.
Giant set of earrings.
We can bring that fashion back. Eric, why don't you tell us about what you did to cut these?
Oh, okie dokie. So again, these parts here, you actually started them in XDesign and then did the pattern in XJet.
And you did, yeah.
So what I did was I grabbed the model, even though it was on the platform. I opened it in my SolidWorks Connected, and at Omax we actually make an add-in for SolidWorks where you can just pick a face of a model. It'll extract the DXF and immediately port it over to our layout software that we use to program our water jet machines. So again, it extracts the DXF. I did a little bit of, manipulating, just kind of reorienting it to, position it best on a sheet, and duplicated it so I could cut two at once. Programmed them, sent them over to the water jet like you're seeing on the screen right now. And it was about 45 minutes to cut both of these out of 40 thousandths thick C110 copper.
And we did it in both copper and another metal, right?
Yep,
Aluminum?
we did it in aluminum as well. And here's a little interesting anecdote. The cut times were roughly the same because, again, the material is so darn thin. But I was also that same day cutting some porcelain floor tiles for my daughter's bathroom. And I had to just make some simple, what we call saw cuts. So I didn't even have to draw a pattern. I could just program a distance. And, I had to switch the material specification in the software. I still had this on the screen. So when I switched the material to porcelain stone, it actually gave me a cut time if I was cutting these out of porcelain. And it was only about 3 minutes more.
Oh, nice. So let us know in the comments if you would like Eric to make you a porcelain tile with a Voronoi pattern.
Maybe you'll get it, maybe not.
Maybe in lots of little tiny pieces.
There you go. I'll send you the scraps there. But yeah, so again, 45 minutes to cut both of these out.
Yeah,
nice.
That's cool. And now that's just one of the designs we created,
Yes.
because Andy's vision was like that first stab, but Chinlu and I also had our own ideas for what the gut guards should look like.
Yeah, we can't help ourselves.
Yeah, so Chinlu, I think I'll take that. You've got another example to show.
So one of the great things about working with CAD to start all of the creative aspects of the design is that as everyone's trying to still figure out, and you heard earlier that everyone had a part in this overall assembly, as they were adjusting different things, the part that we're working on, the gut guard, would have to be effective based on other elements that might come into play. So we were really trying to decide where to place these little clips that would hold this gut guard up. And we actually started out with an old school practice of just taking cardboard and just tracing the shape and seeing how it would fit in the space, where you would come across like weld beads and bracket locations, even though that was all in CAD. But a lot of it is really practical that you can't really appreciate until you are there in real life. So having that and going back to CAD and adjusting it was really critical. And from that DXF, as Eric was mentioning, I could actually extract that directly from CAD and go into a vector-based tool and do all that I want to do with it. And if you've ever watched the SlugMe 8 make, we used quite a bit of the laser cutting to do like a pseudo stained glass design.
That was so incredible.
Yeah, which
that was beautiful.
I really enjoyed that. And we really worked with some of the various colors of acrylic, and we learned a lot about their behavior. They're like finicky kids, I can't even say the word. And different colors, especially black color, just sucks all of the heat and it does what it wants. So I tried to take what I learned from it and apply it with this new design. And I was really impressed and enamored by this new Slug Me 9 pattern that look like streaks of tire tracks on the road. And if you have seen it, it looks very much like something that went really fast and just drifted around, a little donut. So I wanted to capture that in an acrylic piece like this, as well as that really awesome Slug Me logo that's been around for a while, and not really change much other than just capturing it as fully as possible, as simple as possible. And that's all you see floated in this protective sheet. What I and we mentioned before, having to work with all these really amazing makers allow us to really share ideas. And talking with Luke, he reminded me that we could have approached this another way. And for those of you who are working with really intricate patterns on things like acrylic or wood or anything like that, you could substitute these inlays with resin. It might fill the gaps much easier. You don't have, like, I have a lot of gap issues. So I've learned a lot, and maybe if we do this for different builds.
And you don't have to peel
Yeah.
off the
The sticky backing, that was fun. That's like a test of your nail strength as well as your patience. So yeah, it was really fun to do that.
I just want to add that although I helped make the Voronoi pattern gut
Yeah.
guard, having ridden those trikes and trying to look forward, that would be the gut guard I'd actually want, because you can
That
see
was-
through the darn
That was
thing all that
specifically for
clear.
me because I'm the shortest one. I'm always looking like below everything. So for me, this is like my perfect height.
So you're probably not going to enjoy the gut guard that I'm about to show you, Eric, because I thought that the gut guard should have a little more 3D-ness. Is that a word? So inspired by the cow catcher or the pilot that you would see on the front of a train, I created this sort of,
bulldozer
attitude
nose. Yeah.
shape. I don't know if that's and on the
Flying wedge.
Yes, a flying wedge. And then on the back to balance it, I created this sort of dashboard as well as a cup holder. And we joked that it needs a cup holder. We almost said we should take the rear brakes off and put the cup holder where the brake handle is.
It's not
But-
that we're encouraging you to drink while you drive,
No,
but
definitely.
it's like basically while you're waiting for everyone to get out of your way, you're like,
Yeah,
let me take a
Stay
break.
hydrated while
Yeah.
drifting. That's a hashtag.
Exactly.
So I actually have it here, and we're gonna show you a little bit later how we put it on the trikes, or the trike, the black trike we have. But we'll get some a closer look at some of the Easter eggs. But I wanted to show you, as a maker, I love the fact that I don't have to worry about part numbers and item numbers and all this other stuff that commercial customers have to worry about. So I multi-body model all the time. I think, Eric, you've used multi-body modeling for years in SolidWorks.
Oh, heck yeah.
I think, let us know in the comments if you've used SolidWorks weldments to model your deck at home, like many of us have. It's a great way. You just model stuff, and SolidWorks manages all the bodies as they get created.
Here's a quick bit of trivia. My dear friend Michelle Pillars, who the Community Spirit Award is named after, was the SolidWorks user that helped drive them towards implementing multi-body modeling.
Thank you, Michelle. That's awesome.
Back in the
Yeah.
late 90s, and it debuted in SolidWorks 2003.
Yeah, that's awesome.
Fun fact.
Yeah, it's been around for over 20 years.
Yep.
Over 20 years. And it's awesome because you can model, and SolidWorks keeps track of it, right? You can roll things back and forth. What's cool, you can do that same exact thing in XDesign, but you can also take advantage of a sort of a next level concept, which is called an ordered geometric set. What you're seeing on the screen right now is these little containers. They're not folders, but they're containers of all the different features. And what's unique about that is they each have their own rollback bar. So if you've ever rolled back a model in SolidWorks, you can't see the stuff down past the rollback bar. And if you have one list of all your features, you may be like, I want to see what's down there because it's a part of a different body. In XDesign, you can kind of take the time to organize your stuff, and then each one can be rolled back in a different state.
One of my
which is-
favorite part about that is you can actually color that entire OGS.
Yeah.
So if you organize it that way. So I always love visualizing them that way.
Oh, for
It's
sure.
a really neat trick.
I mean, there's so many incredible innovations that have been built into these X apps. When I first saw them, gosh, what was that? 6 years ago now when we were doing that?
I primarily use the X apps because I'm a Mac user. I know. Why am I
Wow.
here?
It's
But
okay.
we support you.
It's definitely changed my game. The fact that I could just stay in that machine and just do all that I want using the X.
And by the way, maybe everyone knows this, but the X design and X shape that you'll see a little bit later are all included in your SolidWorks for Makers license. So the guys talked about it earlier, $38 for a year.
And
yeah,
it's all,
SolidWorks as well as the browser-based app. So
it's all browser-based, all cloud-based. So
Yeah.
if you have a good internet, and you're good to go.
I've run the X apps on my Fire tablet.
Yeah,
that's awesome.
on my
Yeah.
iPad, my phone, my iPhone. Yeah.
Cool. So what I think we're going to do now, we have a quick video that you can watch to show how these gut guards were made. Then we're going to get back over to Jordan, who's going to talk to you a little bit more about the fenders.
Time for the montage.
All right, let's do it. X shape, it was unavoidable. We've shown it in every previous Slug Me that we've been a part of. And we tried to like step back away from it to not overload you guys on all the sub D modeling, but it's so easy. It's so convenient. It's so quick. And we've got a new vacuum former here in the lab. So it just set itself up perfectly for a really cool fender design. Now, typically when I'm doing subdivisional modeling in X shape, I'm starting with like a primitive shape. And what you're about to see here is taking just a primitive surface, a rectangle, just 4 corners, and forming it into literally like virtually vacuum forming it into a front fender on this bike. Now, typically I'm using a solid. Here I'm using a surface, and it was pretty nice because the easiest thing about subdivisional modeling is only adding detail when you need it. Now I'm adding like all these loops for more detail, but it's at the necessary points. You want to keep, just like a spline, I always say, you want to have as few points as possible and then add more points as you need additional detail. So this is kind of a fun workflow. I want to point out too, if you're timing this, it's probably about like 3 minutes of video, but in real time, it took me about 6 minutes to model. Yeah, I knew every step that I was about to do because I clicked through it a few times, but that just goes to show no matter how much experience I have with surface modeling, no matter how much I've practiced the clicks, this would taken a lot longer, hours, to be able to generate the shape set that we do so easily here. So what I'm doing here is kind of a cool workflow where I start with a flat plate. I brought that third dimension up, and now it's still kind of in a flat orientation, but I'm going to start wrapping it around the wheel as a final step. So this is all of the same process as I was just talking about. Add complexity only when necessary. So having it wrap around the wheel or the tire right away from the get-go would have been a lot harder to extrude all those surfaces from it, translate all of them all at once. So we're saving the arc bend tool for the very final step. A little tip, if you are using X-Shape, since there might be a ton of people out there, since we have so many makers licenses out there, always never pre-select the geometry as you're editing the arc bend little bendy thing on screen. I like to set it up in the right position first, then select all the vertices, and then as you bend it, it will deform as you'd expect it to. Now, the other cool thing about X-Shape is we're working in a mixed modeling environment where we have SolidWorks geometry, and here I'm snapping to the face of Andy's cool little zip tie mounts. You'll see those in a little bit. And I was able to mate that face directly to that geometry that was created in SolidWorks. So you can get a perfect fit to other geometry and make sure that the assembly process goes as smooth as possible just by snapping one face of an X-shaped design to another face of a SolidWorks design. So there you have it. I thought it looked pretty cool. Again, just over 5 minutes of modeling in real time. And now what we're going to do is show you how to actually manufacture this on a vacuum former. So we'll head over to Sal's station at the vacuum former and check that out in just a second. Take it away, Sal.
Thanks very much, Jordan. Yeah. So I'm here with Luke. We're going to do some thermoforming today. This is actually relatively new to me, but Luke's got some experience. What do we got going on there, Luke?
So we're just preheating because it takes a hot minute, literally, to heat up. And we've basically got a 3D printed book. Obviously, Jordan just took us through a bit of the design. And we've got some examples of what those books look like. So these are 3D printed. You can kind of get away with doing a few pulls on these. Because it's a thermoforming process, you're basically draping hot plastic and sucking out the air to make the shape. 3D prints can kind of hold up well if you build enough walls, but too many and it starts to distort, as evidenced by
so
previous iteration.
We learned that hot plastic over over plastic, and then pull a vacuum over it, you can kind of really deform the material as well as get all this dimpling because that's where there's no infill. I think the other thing we learned is that on this first one, we sort of hollowed out the inside quite a bit to save on filament, and here we beefed it up a lot with.
I think Andy put this really cool little hand pull feature, which I really like because for pulling, you got to pull the book out, and the plastic's grip tight to it, so it's quite nice to be able to pull it out. And these little air hole features.
Well, yeah, that's the other thing, right? So if this has a lot of ridges and valleys, right? And if you didn't have these little tiny pinholes, when you pulled the vacuum, it kind of just be like the suggestion of
you'd get a little bit because it's thermoform. It almost make like an airtight seal on the outer perimeter, and then none of this will get any details. So those holes are really critical. The old-fashioned way is you just drill holes. You test it. If it's bad, you just drill a hole.
That's
so this is the modern way of
and it's kind of cool because I had no idea. Yeah,
we're pretty close.
Okay.
We're pretty close.
All right. I had no idea how many holes to put, right? Because it's the first time. So I'm like, just put a couple. Yeah. And I said, worst case, we just drill it. But like you said, the modern day, we'd add more holes to the CAD. We just design
it. Yeah, exactly.
So that's really cool.
I think we're pretty much good. We're going to push this back. And basically what I normally do is you can kind of just tap and check and see that the plastic's pretty ready to go. We'll give a few seconds. Are you ready, Sal?
I'm ready when you are.
Okay, let's go.
So it happens fast. Here we go.
Here we go. Yep. Oh, no.
Oh, we blew the seal.
Well.
Right. Okay, hey, it's live TV.
Yeah. So come have a look around here. You can kind of see what we've lost is this thing on the back has popped out, and it means we have no vacuum. So, yeah.
But we can show you what was supposed to happen.
Yeah, we can show you exactly. This is exactly how it looks. It didn't fail terribly in the slightest.
So what you're seeing in here is our rear fender. This is our front fender. And yeah, let's go take a look at the real bike.
Yes,
and
let's go look at the bike.
What things look like. So this is the rear fender. If you want to check it out, I'm not sure which model Jordan showed, but it's actually very similar to the front fender, right? It's got that same aesthetic.
It does,
So yeah, it would come off of the thermoformer just like this with some
flanging that we have
to cut off.
Yeah, have to cut off, and it's pretty relatively easy. You can score and snap, which was a new thing for Sal, I guess, when we were chatting through it.
I was so nervous.
It requires a little bit of confidence. You basically just make a point of propagation. You just cut it and bend it, and the plastic just snaps.
Yeah. So this is the front fender. Came out really great. And then Andy modeled these really cool custom brackets that just use zip ties to hold that on. So zip ties are not good for motors, but they're okay for fenders. So that's the lesson there. I did also want to show you, this is the gut guard that I modeled and showed you earlier. It's on the bike now. And if you come around this side, the couple Easter eggs that I added, we've got the cup holder we talked about. So that's Chinlu's mug with Woodstock on there. But if you look at this when you're seated, you can see the SlugMe logo is elongated, but if you're down at a sharp angle, it kind of squashes back to the true aspect ratio. And then the other thing I had some fun with, I asked Todd about the date of the very first SlugMe, and that's what's shown there on the dashboard. It's also a nod to Back to the Future that's in this Time Circuits style. So we had some fun with it, and it's looking like a great trike. At this point, I think we're going to head back over. Oh no, we're going to head over to the other bike. I forgot about that.
I promised to show you guys a little bit about what happens to the acrylic as we light it. So Todd had this great idea when we were thinking of using the acrylic in between the sheet metal pieces, which was to light it up on the edge. And since we're doing this, you might want to come around and see it from this angle. But you can actually see when we turn on the LED strip, which is a nice SolidWorks red, you can actually see the SolidWorks logo kind of floating and in lit. What we did was we trapped most of the escaping light with this gasket. Tip for adjusting gaskets corners and making them nice and tight is really just to stretch it as well as you can, clamp all of the edges together, and with a really sharp box cutter or knife, score it through both and then just come right back together and they're perfectly married. So it was fun. Thanks. We're going to go back to where we said we were going to go back to.
Yeah, I'm sorry, we were just interrupting. So yeah, Andy, do you want to talk us through what we started with on the design here? And then
Sure.
we'll
Yeah.
interject?
Hi, internet. Yeah. So we made this number plate here, which is totally flat, right? And then we wanted to do like this SolidWorks cube, which has this like 3D-ness to it, right? It's kind of like punching out a little bit. So then we tried printing it, right? So we're running into a ton of problems before Luke showed up. And we're trying to print it, and we're running into all these issues where I found out through lots and lots of Googling, this is called pillowing, right? A slightly sloped surface. It's not a wall. It's not really the top surface. And like with 3D printing, sometimes like you run into issues with that. And we were running into just tons and tons of issues. So I kept trying to print this W over and over again because I was like, the W's bad. If I can fix the W, then the whole number plate will be good. So then,
I mean, like fundamentally, the thing with slicers is they're not really intelligent. They don't understand their design intent. They don't understand what is the A side and the B side. So
Right.
it's almost better, I find, to bring it into CAD and actually design away that stuff. So we looked at various options for the letters, and we found that yes, we could design in CAD. We could do some nice, neat support structures in CAD, but the time saving wasn't going to be very much. It was like 4 hours to print the letters, or it was going to save like maybe an hour at most designing in CAD. So it wasn't worth your design time to do that.
Yeah, and the solution was to print it upright, print it more upright, and then we don't run into that pillowing, right?
Yes.
So
the general rule is normally keep your detail face perpendicular to your print platform,
Right.
because your Z resolution is much higher than your XY resolution.
Who
as
is
well.
this Z that I keep
It's
hearing
the Z
about?
axis, like the up and down.
Oh,
you got,
right,
you
right,
got your
right,
X, Y, Z. So
Yeah, from Pulp Fiction.
yes,
Z-
from
Z is
Pulp
that.
Fiction, of
Yes.
course. Yes.
Okay. So, anyways, so this is, for this print, it made sense to like, just printing the W, which now looks like an M on its own. Do you have a fancy name for M?
M.
Okay. So like this on its own upright is like an hour, but with this support structure that's automatically created, it's like an hour and 40 minutes. Not a big time difference or like whatever. I'll just throw it in there. I'll have it automatically created.
Yeah.
Now the time difference, to print this thing upright with that same support structure was 14 hours, right? And we were running out of time, right?
Yep.
So why don't you show us what you decided to do with
so
like
there was a little resistance, and I guess because it's for new things for guys who haven't seen it. So what we have here is we've basically done like it's like a picture frame hinge almost. So anytime you see a picture, you have this kind of hinge support. And actually, if the model can print stably upright, and there's no problems, you can print it that way. But for this, we obviously want this nice curved face. We've got all these little overhangs. And so actually in CAD, we just modeled some, were they 2mm ribs we went for in the end?
I think 3mm ribs,
3mm
with
ribs, and we neck
0.5 millimeters contact
So
point.
basically, if you just look here, we basically neck that part right in just before the part. And the real benefit of this is we can literally just snap it off.
And that's it. That's all the
it,
support
yeah.
that's on.
And this finish is good.
It just blew my mind when you showed me this. I'm like, apparently, you know, when in cool kid circles that you run in, everybody already knows this, but
Not
I was
everybody,
unaware.
Yeah,
Like this
it's
is
not in everybody. And
so
these,
cool.
even
These
these
just
little brim
peel
strips that
off,
we've made.
whoop, it's gone, and then you can hit it with an X-Acto knife if you need
Yes,
to. Or
of course you can.
A little
yeah.
bit of sandpaper, but like these
Yeah.
just pretty much these,
But
and
we
these are
even model
modeled in
these.
too.
You even model these in CAD because the slicer typically will just do a brim around the entire perimeter, and you don't need that. Like if anybody's had a print and they're curling up the edges, it's all about trapped forces when you're printing, and so we can resist that by putting a little more surface area in the areas we know that matter. And so this is a great way if you're doing prints to save on filament, save on time, and actually you really own the process of how that print works.
Yeah, so then we just printed these, you know, at an angle, and these are, you don't even need glue there. Press fit, it's all done, good to go, right?
It's not going anywhere.
That's that's not going anywhere, right?
Yeah.
Every dad before a road trip ever.
Yep.
Okay. And now we're gonna put it on there, and actually, I want to hear you trade with me here.
Yeah, I'll show you them.
I was actually, I was thinking this would be on GrabCAD somewhere, and I couldn't find it, so I just made it. Right? It's basically this little clamp for a zip tie. Right? So this comes right through here. Zip tie ends up there, and then we go around into these. Am I doing it the right way?
Yeah. Yeah. So we get the tail in.
I got that's just a swept cut in there. Whoop. No supports, just slides right through. And then this guy goes here. And now we're gonna get it on the bike.
I'll hold that around you. You can do that side.
Yep. Now, as we push it through, it'll just automatically link up. And then conveniently, it's in a spot where we can't possibly get anything to cut it off with because it's behind the triple tree. We'll figure it out though. We'll get a cutter in there. But yeah, there we go.
That's it. Yeah, I love it.
Now we got a number plate.
Great.
Cool.
That's it.
And
Thanks.
that's that.
We can head back to the desk. I think we're going to go to Shreyas and Kirby now.
Let's do it.
Yeah.
Yeah.
Cool. So I'm here with Andy Shreyas. We're going to talk about some cool industrial grade 3D printing this time.
Yeah.
Some higher end, big machines because I love FDM, I love SLA and that. But these are the machines that aren't always
That's right.
accessible to people.
And what are we printing? Chain
So,
guard, I
yeah,
hope.
Sh-
Chain
Shrey-
guard, I hope.
Yeah, we looked at the chain and we were like, that'll be fun, Shreyas, who loves his simulations, one night sitting in the bathtub was like, I'm going to see if this seeing if this chain is actually as lethal as it is, and I believe you have some results on that one.
That is right. Well, the very first time I saw the proximity of the chain to the driver's seat, I was like, hang on a second, are we missing a part here? Are we missing a chain guard? And I was told there's no chain guard on it. Like, and I knew I had to run a simulation, like a high torque simulation, where just trying to find out if the chain snaps and what happens if the chain snaps, because I knew Andy was not going to believe me. I had to convince him. To, really understand the impact this could have on the driver, right?
Yeah.
So basically, what I did here is what you're looking at is, I put our advanced simulation roles applications into action. By the way, SolidWorks users have access to these, right? I put them into action, model the chain, model some damage properties. As you can see, probably maybe, zoom in here a bit. You can see how it snaps off. The outer link snaps off.
That's not a
right?
video. That's live. What you're showing there, live results are showing.
Oh yeah, of course
So
it's
cool.
live. Yeah, look at this. I can
see
move
how
things
everything is
around,
like
yeah.
smashing apart and then
Yeah.
like flying off into space. Like that is nuts.
Yes,
Yeah,
and
really cool, man.
And it flies off with a very high velocity.
What is it? What's the velocity
full
in freedom units?
It's high. It's
It's
high
high.
enough to
Okay.
break
It would
off
hurt.
the. Yeah, it's high
Okay.
enough to tear
It-
apart the seat.
It'll hurt.
Right. Yeah. It
It looks
will
like.
certainly hurt. Right. So the bottom line is, guys, we need a chain guard. and we need a robust chain guard.
I mean, yeah, I enjoy dabbling around in SolidWorks in my spare time. I made
Yeah,
a
so-
lovely one. You know, my company branding, 3D Print UK.
Yeah.
Threw some hexagons on there because nothing says 3D printing like some hexagons.
Yeah, you got to have some hexagons. I also like Kirby and I both like created one, and like Kirby was pretty confident about his, so he actually like made sure that everybody knew which one was going to be the best one.
It's also,
So thank
to
you
know
for
whose
that.
is whose.
Yeah. And this is the one that Jordan and I actually came up with, modeled this up in X shape. I think, Shreyas, you decided already which one was the better one because you immediately simulated mine to
I
show
did.
why it would not be good enough, right?
Well, I certainly did in a fairly, minimal amount of time, I would say. The one that you did, right, the one that you showed right now, which had some organic patterns on it,
Yeah.
It is good, right? It certainly takes off a lot of energy from that chain snapping. It certainly is not going to let the chain go ahead and hit the seat, go ahead and hit the driver.
Mhm.
But I mean, as you can see closely, right, as soon as the chain breaks off, snaps off, and then impact the guard, it breaks into further pieces
Yeah.
and things fly off through the gaps you have.
Yeah.
So I guess
So
I don't
was
know.
like-
I'll leave it up to you.
Yeah, yeah.
I'll leave it up to you on what you want to do. We want an enclosed structure.
Right. So yeah, so that's what I did is I just like closed up the gaps, right? Like with a really simple CAD. I did this in SolidWorks. Just kidding, right? Like how long would that take, right? So I actually did. I used X Generative Design or 3D Pattern Shape Creator for this, and what I did here is I actually created a volume, and then inside of that volume, basically just I said, give me, 500 sample points, like random points inside of that volume. And then from there, I used this Delaunay node, Delaunay. There's somebody in the
what's
chat.
that?
Tell me how it's pronounced. But basically what it does is it's saying every single point within 35 millimeters, connect a bar to that point, right? So that's how you get this like crazy looking like mesh shape. And then after that, it was pretty much just say every line is a cylinder, every point is a sphere. And then what I did after that is I spent a ton of time trying to take, let's see how many, I can actually find out for you how many it was, 2,873 different items, right? And I was like, combine this all into one solid. And it took me, I spent probably 10 minutes setting up the first part and then like hours trying to get everything to combine together. And then I told Kirby after I finished it, and Kirby was like, dude, like you could have just given it to me.
And I would have fixed it.
Yeah.
Like at 3D Print UK, we get a lot of files that are all over the place, and we take some time and we fix them.
Yeah.
Every file that comes in gets looked at by someone before it gets printed.
Yeah.
But this kind of design on FDM would be a nightmare.
Yeah.
SLA, same kind of thing.
Totally.
So many supports. With powder bed fusion, you don't have that. You can just
Right.
get away with these shapes. Everything is suspended within the powder.
Yeah, that's so cool, man.
so-
I like once I knew that we could use that kind of technology, it was like, whoa, like
Yeah.
no guardrails. Let's
Yeah,
do this.
Don't need to
Yeah.
worry about how it's going to be made. It's just chuck it in there. Other parts go in there. So we're producing 100 to 500 parts on each printer.
Yeah.
Close to 10,000 parts a day.
Right.
That we produce. And yeah, we've got access. We give the public access to millions of pounds of 3D printers for a minimum purchase price of £40. So while
That's
these
so cool.
machines are quite cheap, like the ones behind us, we give you access to the ones that are not as accessible.
Right.
And yeah, we're going to roll a little video now. It's going to show you our facility and how we actually produce some of these parts and the little technologies and post-processing that we use. So
Awesome,
we'll roll
man.
that video. Now that we've finalized the 3D model and the 3D design, we can then go across and log into 3D Print UK, where we'll upload the file. We'll use the upload and quote button. You can use an STL or a step file. I'm just using a step file. We will let that load up, have a little think, and then from here we can select the material. We can also select our finish and the color of the part. And then we check out with this instant quote and get our parts manufactured. Okay, so Andy, where are you going?
She did this.
Right, so we got one of the chain guards here on there. We got the other one
Yeah, we do.
just loosely mounted over here.
Big fan of this one.
Painted it red. Trace told me red is bad, so I covered it in red to show that it is bad.
It's all bad.
But it's great.
Yeah.
But this one's a bit more tricky to mount on.
And like when this is online, like it looks like it's like looks like it's gonna be like soft. Like this is the nylon printing this in nylon. This thing is so rigid. It's crazy. Like I'm super impressed with the material.
It's super strong, and we were showing you on that. We actually didn't need this. Yeah, I thought it was going to wobble. You know, I think a lot of these drift bikes, you think motor is going to vibrate. There's no vibration because it's all electric. So
boogie, woogie, woogie, woogie.
So I got this on here, loosely mounted. We're gonna pop and roll there. I just want to admire the knolling over here. Tell me your ADHD without telling me your ADHD.
Yeah, right? Like that's
So-
not how my tools look.
Neither do mine.
Basically one big pile. Or actually several small piles in weird spots.
I know.
Yeah.
So just these two simple screws that also mount directly to the motor. It's going to stay exactly where
You're
it is.
good at that. Is righty tighty
I've
in
been
the UK
practicing.
too?
Yeah, righty tighty, lefty
Okay.
loosey. Put that back, or Jason will shout. So this is where I noticed we didn't need to actually fasten these because that is not going anywhere.
Wow. Yeah.
That's strong and rigid. And that's only about 3 millimeters thick.
That is crazy. 3 millimeter thick nylon, and it is like so rigid.
So we ran
Wow.
this chain guard yesterday.
Yeah.
With Shreyas, who tried to prove that the chain will break.
Oh yeah,
And
I heard from his.
and
FBA
it did.
days. Yeah.
And you know, I saved his life. But I 3D printed a couple of extra things. I found that the handle was just this plain piece of metal with a bit of foam on. So I created this nice
Hey, a
little
pattern.
Yes, I used the pattern.
That
This
is
was
the king
all,
of patterns, would
all
be
done
the
in SolidWorks.
Duke of patterns.
It took me ages. I don't know how to use all the little nodes in that, but
Yeah.
yeah,
It
this
looks
is
cool, man.
this is also printed in a MGF nylon.
Yeah.
It's shot peened and dyed. I got some parts here that's vapor fused, which is a new technology we was experimenting with, which uses a chemical.
It looks really. I
to
don't know if the
smooth
camera's
parts.
picking up like how smooth it looks, but like it looks really cool, and it's like so hard. Like it looks.
All of it is hard. I mean, it's not going to break.
Yeah. Now this looks like it's out of like stone. It's been chiseled out of stone. Right?
That was what I was going for.
Yeah,
I
yeah,
wanted-
it's so cool. And like when I first saw this, I actually saw the CAD of this before I saw it in real life. I was like, oh, that's like a cool like tessellated shape. Like I wonder how he did that. It's all champers.
Yeah.
You just chamfered all over the thing. Yeah.
Just find some edges, chamfer it.
Yeah, you don't necessarily need like some high-end tool to create like really cool looking patterns. Like you just have to be creative sometimes. Yeah, so
like
this is awesome.
Yeah, that came from my days in university. I didn't have access to all those great platform tools.
Yeah.
You know, I had to figure it out myself. But with stuff like the Makers Edition, you get access to some of these tools.
Yeah,
you get access to so many more powerful tools. And having, you know, user group meetings like this.
Yeah, totally.
You learn a lot from it. You know,
Yeah.
I remember when I first learned how to do screw threads, I did a whole sweep cut and went crazy with it. I learned a lot about servicing until I figured out there's a button for it. Okay? That blew my mind.
That's awesome.
But yeah, so those are the items that we decided that 3D Print UK will be good for printing out. You know, have these very crazy, wild shapes. That's a lot more difficult to do on your desktop machines.
Yeah, super cool, man.
Yeah,
love it.
But you guys wanted me to do a chair.
Well, yeah. I mean, I was like, why don't you just 3D print the chair? Like, what's wrong with that? Well, like, this is a boring chair. Let's like 3D print a chair.
I agree with that, but the machines that we have, this is a bit too big for that kind of thing. It's a lot more complicated.
Okay.
And with the powder bed fusion, you don't want to go too big.
Got it. Yeah, that makes sense.
There would be a lot more complications, but there's a team at the table right now that's going to show you guys how we actually went around making a seat.
Great. I feel like I should join them.
Yeah, I think you got to be there.
All right. We're back here at the desk. And man, we've been talking a lot about how kind of cool we're making these bikes look. And I'm sure you're thinking, well, do they ride and how do they ride? You guys stick around. We're going to be ripping these things all around the parking lot afterwards. So make sure to stick around for that. And hopefully none of us gets injured, especially Jason, because you can't really trust him anywhere. Yeah. Anyways, the next thing that we're going to cover is what I think is probably the coolest thing. Every single one of these things, from the vacuum forming to the 3D printing techniques that you shared to all the different types of materials that we use and fabricating processes, I hope you all are learning a ton. This particular workflow is something that I didn't even think was possible in a DIY environment, and that's building a whole full-size seat and molding it. So thanks to our friend Luke, who's very smart, he gave us a clue as how we could possibly accomplish this. So we're going to show you designing a brand new seat from scratch and actually be able to manufacture it, right?
Yeah, I mean, the wonder of this kind of process is that it uses the standard triangle of manufacture. You've got like time, quality, or cost. Like you've got those three, and you can have any
gravitate towards.
Yeah, you can, and typically makers gravitate towards that. We have time, and we want quality because cost is always a critical thing. But if you don't have that time, then you're going to have to spend the money. And so, this process is no different to that. There are many economical ways to do it, but this is a silicon jacket and mother mold. It's also known as a matrix mold, and it has several other names depending on what part of the world you're in. But this is a form of low volume manufacturing, basically. So forget about injection molding or large scale like that. We can do something around about 30 to 40 pieces, maybe even 50 if you're lucky, depending on how the silicon lasts. But you can do that in your garage, which blows a lot of people's minds. And most people,
blew my mind.
Yeah, well, most people are hyper focused on like, I'm going to make one or I'm going to make 10,000.
10,000, yeah, exactly. Where's the in between?
There's a bit in between. And low volume manufacturing like this, for people industrially, sometimes it's referred to as soft tooling professionally. But in the amateur scene, certainly for props and prop replicas, which is our world, it's literally the bread and butter for everything we do, because that's kind of the sweet spot that most people are making.
All right.
And so, yeah, we've got these shells here that we can kind of show off. You want to show anything else first, or do we want to dive straight to the shells? Like,
well, let's talk about like, why don't you tear one of those apart and just go over like the general
concept.
General concept.
Okay. So we've basically got these gray parts here, and so we've got These are representing our like outer shells, and typically
that's like a huge hunk of metal.
yes,
In
yes, a
traditional
huge rectangular,
injection
rectilinear, like solid piece.
Yep.
But in the world traditionally for doing it for props or even low volume manufacturing, this would be a giant monolithic fiberglass shell.
Yeah.
And it would have been crafted and formed and take a lot of time. And it requires artisans to do that kind of work. We're in the CAD world now. Obviously, I'm an engineer myself, and so really developing these workflows in the world of CAD is really what we're all about at Orbital Effects for bringing new tech and using it to make things. So these hard shells we can 3D print. 3D printers are getting bigger and bigger, and they're getting better and better. And the quality of a shell doesn't need to be very good. It just needs to be mechanically sound. And so you can see the detail is not great on these, but it doesn't need to be. It's a shell, and it's offset from the part. What goes in between this and our actual model, which is this little gray chair here, is this red stuff here. So can you just separate that out,
Yes,
Andy, while
yeah.
I grab this? This is kind of just a representation of our silicon. So what we kind of do is we just slide it up there.
Oh,
you're good.
Got it.
You just need the knack. So basically, this red here simulates our silicon layer, and basically when we're waxing it together, we basically will pour silicon into this spout. It will fill and create this part of the mold. And similarly, on the other side, we also have a fill spout on the other side.
Yep.
So we've got one there that allows us to fill our two halves of the
peculiar
mold.
position, but
It is, yeah. Well, also, like, you typically pick areas that are not important because that's where bubbles and things and mess is going to collect. So generally, that's your two halves of the part. And the crazy thing is, you put this together, and then we're going to pour. We're basically going to pour urethane foam into there.
Yeah.
Which, not expanding foam, so
Right.
not the DIY stuff you go to Home Depot or B&Q or whatever your preferred orange home supply is. And basically, yeah, B&Q, that's our Home Depot in the UK,
Alright.
basically. Also orange.
Also orange.
Also orange, the same
Nice.
orange, I'm fairly convinced. Anyway, so we use polyurethane foams. These are like professional grade materials. You can buy them from Smooth On, I think Brick in the Yard, Mold Supply here in the States.
Yeah.
There's several suppliers, but kind of look at them and play with them. They're kind of flexible things. If you've ever sat in a roller coaster and you felt that kind of like squidgy but shiny material, that's most likely urethane foam. You can work with them at home. You just have to be aware of the precautions. So like with all things, read the data sheets, know the chemicals, but you can do this in your garage at home. It's a procedure that as long as you're safe
enough,
you can do it. Yeah.
Yeah, that's amazing. And the other really liberating thing about this, not only being able to do it in your home, but the design is a lot more flexible because the material is flexible.
Yes,
So
yeah.
the silicone is flexible going in here, and
Yep.
it will just like flap into crevices
It will.
that you'd normally not be able to do with like making sure a draft angle is consistent at the
Yeah.
parting line and
Well-
everything.
Well, also as well, like we can get away with undercuts. You
Undercuts,
can't-
yeah, exactly,
In
yeah.
traditional manufacturing, you can't do that. We've
That's
actually
what I was
got
saying in way
some
more
of the
words.
material here. Actually, that's lovely provided by Mr. Dan Wagner. So this is foam. There's many ranges in this, but basically this is a rigid foam that we'd use to fill the core. And yeah, it would do great. It'd be perfect for it. You can kind of just see there's varying different models that you can get, and this is just one example. There are other suppliers are available.
And that's
Um,
like one of the trickiest parts about putting like a crazy pattern on something like that is like if the requirement is no undercut, like
oh my
you're
God, yeah.
severely limited to where you can put a pattern
Yes.
or how you can put it on there. So
Well, until you
so,
get
yeah.
to like industrial processes like making giant steel molds or like compression molds, which are really expensive,
Yeah.
or even hard fiberglass molding, like it can get very expensive very quick. And so for makers, you've kind of got to take the battles you can. And I
Yeah.
think with this process, yes, we could print this as one monolithic, one large piece, or you could tile it. Like printers like the Bamboo Labs printers
Yeah.
are so fast now, you could print one of these in a week and just build them together like a big jigsaw puzzle.
And then you said 30 to 40 to 50 runs, but
Yeah.
that's the lifespan of the silicone.
It is, and
so
at that
you
point,
still
all
have
you
this
do,
mold.
and then you put the master back in, pour more silicon in, and then you continue to run it. The
Yeah.
shell
Yeah.
lasts for as long as you look after it.
Yeah.
It's really awesome.
Yeah, it's great.
It's a sweet process. So it was a fun process doing this. Luke was here to, Andy and I were flying blind with the process, but we
Especially
can
Jordan.
model.
Like, I kind of had an understanding of what was going on, and
There was-
Jordan was
there was a
constantly
lot of
like,
trust the process.
"But wait, it's going to be soft." I
there's
was
an
like, "Yes,
undercut.
there's
There's an
going to be
undercut."
soft."
It
It's
was
like,
so
stop
foreign to
asking
me.
me that.
It was great.
So yeah, Luke was kind of like our coach along this modeling process. So he was telling us what to do and when. And the first thing that we decided was there's already a seat on there. We rode the trike, we test rode it, and it was actually a really comfortable seat. It was pretty functional, but we wanted to incorporate Jason's crazy sketch and stylize it more and actually make it a little more comfortable with the squishiness of the foam. So one of the things that was really important to us is like Andy and I aren't pros at ergonomic design and
Correct.
matching body
Yeah.
forms and things like that. So we wanted to keep that inside surface really accurate to the original, right?
Yeah.
So well, Andy, you recruited some friends.
Yeah, so shout out to Andrew Miller. I only hang out with Andrews over at Trimec. He actually used one of the, I believe this is called the Leo. It's one of the Artec 3D scanners, super high quality, and you can see it like shows up on the screen there. And he just like, it took him like 10 minutes, and he's like, "All right." And I'm like, "You're done?" And he's like, "Yeah, it's done. Yeah, I'll send you the file later." Right, and like that was it. So I mean, just hit it from a couple sides, and now all of a sudden we had like a really super accurate scan that we could just drop right inside SolidWorks, right inside the platform, start using. Yeah,
super great. So therefore, with that, we didn't have to try to pretend to know, how to perfectly fit a seat and style it and all that stuff. So the next part was the frame design.
Yeah, because
And-
the foam is soft and ductile, and
So
so,
we
like
were-
you're just gonna have a big squidgy,
whoops,
broken,
Yeah.
destroyed.
It would last forever, and you could keep
Right.
on reusing it,
I'm
right?
done, I'm done.
As long,
I'm out. As long as you don't drop it on the floor.
yes, yeah. But yeah, this design squishy.
Yeah.
We do have some webbing here to kind of
We do like
hold
it would
together.
you'd
but
accelerate and you'd just like
Yeah.
spring back, but it
You'd
wouldn't
be wobbling all
it
over the
wouldn't be
place.
great. It's
Yeah.
already an unstable enough ride as it is that I think adding more would be dangerous. And
Yeah.
So we talked about introducing overmolding effectively, and so what we talked about here was basically using a steel frame. to put it
I hope
back
you're
in.
catching this on camera. This is
I
the
hope
best
so.
part.
I hope so.
Wide angle.
That was wonderful. And so we kind of talked a little bit about making some form of steel frame structure. So I kind of just said to you, we need a steel frame structure that we can cut, and you just went away, and we had to do a little bit of changes.
All right. Listen, so I'm going to use weldments to build this frame, and I just want to make like some PSA, public service announcements here with weldments. I watch so many people at our customer sites, at user groups, use weldments the hard way, and that is building a structural member, building another one, manually trimming it, and then another one, manually trimming it. You don't have to do that. All right, so let's jump into SolidWorks here, and I do have a sketch started. And listen, this is another announcement. Don't be ashamed of creating a ton of planes and sketches. It's totally fine. You don't have to pretend to know how to use 3D sketches. We don't use them that often. So just stick to what you're most comfortable with, put it in a folder and hide it, and it looks like a 3D sketch, right? So
You're a professional demoer. You know how I can tell you're professional is because your taskbar is shown.
Yeah.
Andy's named the folder.
Yeah, sketches.
Yes.
Yeah, I didn't even give it away. All right. So as we're using the structural member feature, as I go ahead and select this, there's just two simple rules. One is every single sketch entity has to be connected end to end. And then the other one is they could be parallel. Definitely take a second to locate the profile. We could pick the top corner, the bottom corner, whatever you need to do, and then hit OK, right, Andy?
Nope.
Hit new group.
You can stay right in here, guys.
Yes, just keep
Keep
on
going.
creating
Yeah.
another group and another group. And here are
Yeah.
some parallel entities, and we can locate those as well and make sure that they overlap by picking a different corner. All
Nice.
right.
Yeah.
So it's super simple, and you could just keep on going and going and going with new groups. And that is what I want to make sure everyone knows, because everyone that I see model with weldments does not do that.
He's tired of the support calls, people.
Yes, I'm tired of the support calls. All right. Let's jump over to let's put this in the oven and bake it a little bit and jump over to the finished design to check out how that looks.
Nice.
And listen, one structural member for this entire thing And yeah, there's going to be maybe some trimming here and there. So
Always a little bit you can't quite get. You
Yeah.
use trim, and that's why trim extend like exists. So
the important thing about using groups, so that I want to point out, is the entities that you select first, the secondary group that you create is automatically going to trim to that entity, right? And then so on and so forth for the following entities. But again, you can override that anytime with trims. Heck, I'm shamelessly using an extrude cut right here to change this from a 25 millimeter to something like a 5 millimeter.
Whatever works.
Yeah,
Sometimes you
whatever
gotta do-
works.
A lot like Jason, a lot of my sketches are also deeply undefined. So
You know what that would have?
Can we just say,
Hey,
like,
hey,
hold
hey,
on,
wait,
hold on.
wait.
Just because they're
drop
doing
that
it,
bombshell in there.
if your friend jumps off an underdefined sketch, it doesn't mean that you should too. Okay, like
it does.
Fully define all of your sketches, people. This is madness.
No. I don't mind an underdefined sketch.
If it's like a spline or a fit for a picture,
This is okay. Your underdefined sketch is not like Jason's. Jason's is all blue. Nothing's defined. It's not underdefined.
Yeah, that's true. Yeah.
It's
zero
non-defined.
Anti-defined.
Yeah.
Anyways, all right. Back to the dump.
Bad news. All right. So yeah, this is a world of designing while thinking about the fabricating process, because normally what I do is I create a weldment cut list and I'd send that out because it's all common members, right? But you told me that you were going to laser cut all these anyways out
Yeah.
of a specific thickness.
Yep.
So
We basically we're going to laser cut this out of a sheet for speed. We're going to put them together and just weld them because time didn't allow for anything more complicated than that.
Yeah.
And
So
that
so
was on the speed.
What
part
am
of the
I
triangle.
concerned about? How the weldment cut list would say that was a 3x25 member.
Yes.
Doesn't matter. It just needs to be accurate, and you're gonna DXF cut
Yes,
it out on a
exactly.
Omax water jet.
Yeah.
Maybe even. Okay.
Why not?
Shipping might be a killer for the UK.
We can
though.
make it out of porcelain.
All right. The next thing that we had to pay attention to is we have this frame running through the center of the seat. It's just going to be suspended in there, right? And but when you're molding this, the silicone, well, not the silicone, but the foam needs to be able to flow in between the silicone and the metal frame inside.
It does.
of
Yeah. Yeah. Absolutely. Yeah.
And I said, like, you know, how thick does that material need to be before it like gets too thin and just starts falling off?
Yeah,
And
yeah. Well, like the silicon, typically there's a general rule which is around about half an inch to minimum, or 12.5 millimeters for those not on the imperial system, without freedom units. And so for us, that's kind of the general rule. Start from there or make it thicker. So we kind of designed this based on a 12.5 mil thickness because it was already going to be quite a few gallons of silicon anyway. So we wanted to minimize that use. And the foam body itself, similarly, again, somewhere between 1/2 and 3/4 of an inch is more than suitable. So we kind of just use that as our parameter to go forward and kind of give us some parameters for how thick the seat should be from the frame.
Nice.
all right, so what I needed to do was figure out a way to make sure that when I'm doing the X-shaped design, the sub-D modeling, that I didn't go past that minimum thickness.
Yes.
Right.
Yep.
So that when we're looking at this design, that's not just picking the frame, combining it into one body, and offsetting it, which would have been easy because it was one part. It's a multi-body part, and that's what Andy's used to working in. I'm
True.
used to working in.
I love a
Sal
good
mentioned
multi-body
he
part.
loves working in the multi-body part environment.
Yep.
It's the ultimate like in context design environment because you
is.
don't even have any file references or anything like that. But here we have fasteners that have to hold it into place.
Yep.
Those
Yep.
fasteners are going to be critical for the mold too, because
They pick up.
that's what suspends the frame perfectly
is,
in
yeah.
the center as the mold is poured in.
Yep.
So there's no ifs, ands, or buts about it. We had to go to an assembly, unfortunately.
RIP.
Yeah. So that said, I needed to not only offset all of these members, but also offset the bolt heads.
Yeah, of
that
course.
mattered too,
Yep,
right?
absolutely,
Because if we had a little thin piece going over there,
You don't want to be
your
bouncing
butt
a
is
bolt in your butt,
sliding,
yeah.
right? And it's just going to tear that thin
Of course,
material
yeah,
off.
yeah.
So what I did was look up on the SolidWorks help menu. Yes, again, I'm not too proud to mention it.
No, I do it all the time.
The join feature. I remember kind of how it worked, but I hadn't used it for like decades, it felt like.
Yeah.
So I'm going to cover how useful of a feature that actually is. To use the join feature, all you got to do is type in join and no results found.
Wait a
right?
minute.
So what you actually have to do first, and this is probably why I never use it, because I never was able
You
to
never
find
found
it
it.
before. You have to insert a new part. To put that part like on a plane, I'll just drop it on there. I don't need to sketch because I'm not going to create any features here other than the join feature. Now I can fire it up. There it is. It appears.
Oh.
And all you have to do is pick the components that you want to be joined into a common part.
Oh, that's neat.
So this is like the combine feature that we have in a multi-body part for an assembly. And again, maybe
Don't
some
forget
people
the
are like,
spacers. You forgot the spacers.
no, I don't.
Yes,
We're
sir,
going to
Robert.
insert the spacers to
We
the
are.
mold.
Okay.
So
So
we
my
just
bad.
wouldn't
I'm
need the
sorry.
Yeah, so this just created a part, and one feature in there is a join feature, and it's exactly what we need. And from there, I could go ahead and offset all those surfaces
Nice.
and go ahead and create the rest of the geometry.
Super cool.
Far less chaotic than my process. Taking random section views and hoping for the best.
Yeah,
Just
exactly.
slide it through the body and be like, yeah, this is good enough.
Yeah, I think it's about right. Yeah, so once we do that, we can also, well, let's jump over to a more finished product. This one. No, not that one. I'm jumping ahead too far.
Do the good one.
Do the good one.
I like that one, but the other
Go to the
one.
right one.
You know what? Let's just stay here for
All
a
right,
second.
good.
I'll show you the finished envelope. Let's go ahead and see what that looks like.
What?
So all I did was take what I just created, the join feature, and,
Yeah.
and offset all the faces with the move face command, by the way.
Yeah, okay.
And then what you can do, let me actually hide this again. Let's say we did all that. All you have to do is go to the custom properties and turn this into an envelope.
Oh, this feels like a hidden secret.
I know, man. I
Open the
tried
whip.
searching for it on the command search, couldn't find it. I'm like, where the heck is the envelope? Yeah, go to the properties of the component and activate envelope. Why would I do that? Number one, makes the part transparent. That's kind of convenient because like it's just like a reference surface, kind of. And then number two, it excludes it from the bill of material. It automatically selects that. So if I did create a bill of material, it's just going to omit
Wouldn't get
that
in the
from
way.
it. Yeah,
Yeah.
because it's just a reference geometry.
Yeah.
Number three, this is a big one. It omits it from the overall mass properties from the assembly as well.
Sure. So it doesn't ruin it. Because we do need mass for what we're doing in the next steps.
It's pretty
Absolutely.
important to figure
Yeah.
that all out. So it's truly just a reference body that's floating there in your assembly without screwing up everything else.
People actually used to use envelopes a ton more before email.
So dumb. But these are old features, and some of you who've used it a lot might be like, dude, what's the big deal?
Yeah.
But I think they're commonly overlooked and so convenient. And it was a lifesaver here because otherwise I would have had to export all those as parts, combine them into a feature. Now I'm getting all this webbing
was a crazy
chain
step, a
of
single,
file
like, merged
references.
lump.
Yeah,
Yeah.
right. But here I was able to do it right here. The best part about it is as we change the geometry, as we make changes to the frame, as we make changes to the bold, if we swap those out, we can go ahead and continue to update that because it's a parametric reference.
Nice.
To the original assembly.
Saving this.
Yeah. All right, now, and the inevitable design change.
Yeah.
I share my frame with Luke.
Yes.
And he immediately, as he tends to do with my designs, picks it apart and tells me what's wrong with it.
I think pick apart's a strong word. I think offer some robust suggestions of improvement is probably probably a kinder. But yes, it was a design change. There was some problems with it.
Yeah. What was it? The frame, right? Your fabricator was like, dude.
Yeah, we
all
because
these
of
are
the
butt
time-
welds.
Yeah, because of the time we had, we're like, well, if we butt weld them together, we're going to need lots of jigs and clamps and crazy things. And in my head, I thought it was totally logical that we were just going to overlap everything and just spot weld it, like bam, super quick. we can do it in a weekend.
Yep.
And then I opened this assembly and they're all butt joints, and my welder's going, this is going to take a long, long time. He's like, I've got a spot welder. We can knock it out in a weekend, but this I can't do. And it's like, okay, can we just add them? No, because then the DXS have changed. And I just was like, okay, I'm going to go back to Jordan. I'm really sorry. Can we just change everything you've done? I feel bad for me because maybe I should have spec'd that earlier, because I guess in my head, the design intent of the speed was clear, but the reality in yours was clearly not.
Yeah, it's the reality is like Jordan's never fabricating anything ever. I haven't either. I looked at it and I was like, this looks great.
He keeps searching for the fabricate feature in SolidWorks, and it's just not there.
I'll fall on the sword. You know, it's a typical design problem, right? Like, mistake is not thinking ahead about the next step.
Absolutely.
And what saved me maybe like 5 minutes of modeling would have cost you out on the shop floor a tremendous amount of like fixturing, jigging everything,
huge
locking
work,
it down, holding it perfectly in place as
And
you.
don't get me wrong, if we were doing something we wanted this feltest, most ideal frame,
Yeah.
this is how we would do it. If
Yeah.
we wanted to manufacture 100 or 200 or thousands.
To be
But, like,
honest,
we
I was
want-
trying to minimize material thickness,
Yeah,
because
and
if
sure.
you do add overlaps,
Yep.
you're increasing the thickness,
Right. Of
and,
course you
and
are,
I'm
yeah.
having to make the seat thicker as
Yeah.
well.
Yeah.
So there was some intelligence.
But you could
into
almost
my
like the
decision.
overlap way also maybe even gets you away from needing to weld. You could just screw it all together.
Yeah.
Like a Meccano set, it could even be that way if you were
Yeah.
that
Yeah, yeah.
desperate on a prototype.
Yeah.
And you could do that without, as long as you get your parts
Once
cut.
you mold it,
Exactly.
it's holding
all-
it's helping to hold it
it's
together
the best form
anyways.
of Loctite you could imagine.
Yeah. All right. So over here in the model was my spot welded design. This was the butt weld design.
Yep.
And problematic. Yeah. Like how do you hold this piece directly to that piece perfectly level? And it would take a
I
heck
don't
of a
think the
lot
flat
longer.
ones were such a problem. It
Not
was
as-
when we got
yeah.
to the crazy ones up
Yes,
here, we're like,
up
"Oh,"
here.
just like holding them at random angles and hoping. For the
Yeah,
best.
yeah. I mean, you could have done that. Put a little
We could have done
glove on.
Yeah, just
All
hold
right.
it nicely.
Don't move. All right. So first thing is something I forgot to ask him. I just assumed 3 millimeters sounds good. I'm sure they
Yeah.
have stock material like that. You said 2 millimeters is most likely what you were going to
Yeah,
use.
because it was easier to get a hold of. But at least it was metric, so you were halfway there.
And yeah. And the other thing that I was thinking ahead about, doing a singular structural member feature.
Yep.
All I have to do to change it from
One-
3
one
millimeters to
switch,
2 is just change it to the other profile.
Hey.
It thinks for a couple seconds, and we've
Yeah.
got a new frame that's
Nice.
all 2 millimeters.
Yeah.
Sick.
That's awesome. Now, the other problem is, okay, one thing to know about structural members, typically big I-beams or
Yep.
angle iron, it doesn't bend.
No, not so much.
So what bends is actually sheet metal.
Yes.
So yeah, I said it. On my Weldmans tab, I have a convert to sheet metal feature.
It's wild. You're crazy.
Why not, dude?
Madman.
We can mix these material and modes together. All I have to do is convert to sheet metal, pick a face, and hit OK. And voila, that's a sheet metal part. You know what that means? I can go ahead and fire up the edge flange command,
What?
grab on an edge,
Stop it.
and just start dragging this out wherever I want it to go.
Sick.
Nice.
Now, I probably want to align it, not 90 degrees, but to that face. Maybe I want to go up to vertex and pick this edge right there. So it's just as long as that.
Easier for
And
clamping, yeah.
we've got ourselves
It's great.
an actual spot weld.
And and for me, this, like when you came back with this, it was so quick. I'm like, I assumed you just redrew the whole thing because I was like, because that's what I would do. Because in the last minute panic, when you don't spend the time to dig into the more esoteric features or things that you don't think are compatible, like weldments and sheet metal.
Yeah.
Sometimes you miss these things. And like for me, this is also why I love coming to SlugMe, because I learn random little tips about things that I've never done before. And so this is a great one for us.
Yeah. And then from here, I was just able to, again, you're a DXF laser cutting all this,
Yep.
right? So
Yep.
I just flattened each one of those out on a drawing and
Yep.
we were good to go. Didn't even have
Perfect.
to add dimensions. That was pretty convenient.
That's the great
Maybe
thing about
one
lasering.
dimension just to make sure the scales
I
right,
mean,
right?
maybe. Yeah, sometimes
about that
it
later.
depends on the laser guys. Actually, sometimes they're like dimension, sometimes they're like no.
All right. The next thing that we had to do was actually model the seat itself. Now, I already walked you through with the Fender whole X-shape workflow, but what you saw just highlighted there, that purple face, was the scan surface from our friend at TriMech, another Andrew, right?
Mm-hmm.
And what I needed to do is, fiddle around with these nodes on the surface as much as I could to match that curvature of that original seat. But what happens in subdivisional modeling a lot of times is you accidentally pick points that you don't want to, and you end up like moving something unintentionally.
Right.
Because it's so easy to edit the shape. Sometimes it's too easy and you end up editing things that you don't mean to.
Yeah.
So we added this awesome new enhancement, the working zone. And what that allows me to do is select a bunch of vertices and maybe invert them so that all those other vertices are the ones that I want to be my working zone. Everything else will be fixed in place and I won't accidentally edit. Jason's face, I just saw electricity like start sparking around his head. I guess he didn't know about that feature. The next thing, really new cool feature in X-Shape is the soft selection. So to match each one of those nodes to the surface, I'd typically have to individually drag each one as close to the surface as possible. But in this case, with soft selection, what you'll notice are these red, purple, blue dots that are emitting from the one vertice that I have selected. And you can adjust how far that fans out. And as I make an adjustment to that one node, it will softly makes that same translation, but at a more delicate
rate
than as it gets further and further away from the main
I
node.
think that's really important for making a decent curved surface, because otherwise, if you're picking individual points, you turn the zebra striping on, you're just going to have like crazy messes everywhere.
This is the same thing with like surface modeling. If you have a spline, you want as few points as possible.
Less is more.
Let
with
it
curves.
let it do the curvature for you.
Absolutely, yeah.
Rather than you trying to do it yourself.
Yeah.
The final thing that you'll notice here is that I've got an inside surface and an outside surface. So again, this is like the best of both worlds. We always compare sub-D modeling to surface modeling. What I did is I just took the inside and outside and merged them together. So as I was modeling the inside, it was automatically isolated from the outside. And as I was modeling the outside, vice versa.
Nice.
So I can make two very different designs. Again, if we take a look at this, super smooth and ergonomic on the inside, and kind of this like sharp, more modern edge design on the outside. Very different modeling techniques for both of those, but just blended them together as a final step.
Super
and that
cool.
made it so easy.
Great.
All right. Speaking of surfacing, Andy, there's more features than just the sub-D shape. There's some details on the inside that required some surface model.
Yeah, so you may actually recognize this from the number plate we were just showing. We used the same type of surface modeling on the seat here. So I kind of wanted to show what that looked like. And, I've been doing surface modeling in SolidWorks for a long time. It's widely known that I'm much better than Jordan is at it. And I actually wanted to show you guys how I modeled this right here. So I'll hop in to this grouping right here, which Sal already called an ordered geometrical set, which
Whatever
is just
that means.
wild stuff. I don't even know what he's talking about, right?
Crazy word.
And I have this tree that I can roll back on, right? And I'm just going to get this one out of the way for us here. And in here,
And as he's doing this, you guys be the judge. Who's better at surface modeling? In the chats, let's hear it. No pressure, Andy.
oh man. There it is.
All right.
I think
Now you guys show the features. Drag it down. Let me help you. A true surface modeler. Show that actual offset feature, and then you'll be good.
Yeah, there we go. Okay, so this is a little offset surface, and what we want to do is go up to this offset surface, which is just offset a tiny bit. I'm gonna, just so it comes a little bit forward,
I'm going to hide that offset for right now. But what we did is cut out this SolidWorks cube shape here, right? Now, the first thing we did is actually add this ruled surface. And what's really cool about this ruled surface, if you know how to do a ruled surface inside of SolidWorks, you can go like normal to surface, tangent to surface in a particular direction. But when you're actually trying to get a particular angle off of like a curved surface, you kind of need to do like a swept surface and be like, there's a lot of things you can do it, but it's pretty complex to set it up, right?
Yes,
there's some tricks that we've used along the way to get it done.
It's
And
not
what
as
I love
easy
about
as
this,
typing in 30
Yeah,
degrees.
you just type
Or some
in
ridiculous loft. Like
Yeah.
modeling it's a weird offset. So
right. So like 45-degree angle everywhere, like 45 degrees to the
Off
surface
the
where
edge.
it's at.
Yep.
Super easy and cool. I really liked that. Like when I first figured out that you could do that. So then this is another one that's just 90 degrees off of that. And we've got this shape that you might think, oh, that's like a swept cut or something, but keeping that swept cut from like, pitching, rolling, yawing as it's
Twisting,
going around,
changing angle.
it's actually kind of tricky. So that was pretty cool. So then we just trimmed away the top of it with that offset surface right there. And then it's just after that, we used the same exact style of features to add all this other stuff, right? Utilizing those ruled surfaces and everything. So after that,
But I think the takeaway here, Andy, was like, we go back between SolidWorks and X Design occasionally.
Yep.
We haven't done much surface modeling in
Yeah,
X Design. We
right.
kind of underestimated how capable it actually is.
It's just this browser-based CAD tool you can hop into, and actually the surfacing that we did with it was actually pretty slick. So I brought in my SolidWorks cube picture. From there, I actually created an offset surface here. I did another tiny ruled surface off the edge, and that's just so I can start doing this cool stuff. So then created a sketch right here, and then use that to split these faces up.
So are you going to manually sketch that whole SolidWorks cube? I want to see.
We're
that
not there
sketch.
yet, Coach.
That's what
All right. So now to make this shape more 3D, right? I actually just created that sketch off the edge here, and then created a plane up here that I could use to create. Did a little split on the edge there, little surfacing trick. Split the edge where you need to create.
So you
geometry.
have a vertice there that
So
you
have
can snap to?
Exactly.
All right.
So now I create that piece right here. Then I chop out the middle so that I can create this filled surface right here. And this filled surface is selecting all these edges.
Ooh,
And
those are-
because I did this little ruled surface off the edge here, I could actually say tangent to that little surface right there,
Got a nice little radius.
contact to
Yeah.
the other, right? And then just mirror that to the other side.
So your
Did the
ruled
same
surface
thing on the top right here.
is determining the angle at which the bulged surface comes off at.
That's
pretty much.
correct. Yeah.
Nice.
Okay.
So after that,
That was
I
smooth.
wanted to create these grooves in here. And in order to do that, hide this out of the way. In order to create these grooves in here,
You just did an inverted fillet.
yeah, that's a tool that you can use, right?
Inverse fillet.
Yeah, so I actually trimmed
Make it
away
happen.
this area in here, right? Used another sketch, right? Some fillets here just to trim away that area. And then I actually did an offset surface, and it's kind of hard to see right here, but I trimmed away the surface underneath with another surface. And then, oh yeah, that's hidden. That's why you can't see it, right? So that trimmed surface is underneath there, and then split the edge there. And now I'm actually able to do a loft. So I do a loft from this edge to this edge to this edge, right? And now I'm controlling the depth of my inverted fillet. So that's the inverted fillet feature, right?
Getting fancy.
Okay, I want to hear what's more intuitive to use, subdivision modeling or surface modeling. This is
Yeah,
why
but this
people
is-
are scared to surface model, Andy. This is
What do you mean?
that,
I'm
that
making
is
it
a crazy
complicated?
workflow.
Yeah.
No, it's great.
And then I do a filled surface in there, and that's the only way that you can create that kind of like geometry. Now, finally, we get to actually get the letters in there, and the letters, it's like, well, how the heck are you going to do that, right? So what we did for the letters is we actually just used that sketch right there, or that picture, I should say. And one of the cool things you do with a picture inside of XDesign is if you right click on a picture, you just say, converts a picture into a sketch. I like accidentally came across this. I was like, what do you mean? Like converts it into a sketch.
Why is it so plainly named? It needs to be more
I
elaborate.
know, right? Yeah, in SolidWorks it's called like auto trace,
Yes.
right? And
it's anything but auto.
yeah. So it took a little while to chug. It takes a few minutes, but eventually like it gives me that sketch geometry that I need. And then it's just as simple as
But I want to spend
it's
6
just
hours with splines. Like
I mean, usually what I'm doing is to be honest, I'm taking in Illustrator, converting it to
Oh,
vector
really?
graphics,
No,
exporting it as a DXF, then importing that DXF into a SolidWorks sketch.
I spline trace.
We didn't have to
everything.
do that here.
yeah, and
Just
so
sketch
trace
and so
everything,
does
yeah.
and this is the 3D printing argument, right? Is like it takes this long to make, but it's idle time, right?
Yeah.
So it takes a few minutes for this to chug. Right. And maybe I could have done some of it like the W I probably could have done on my own, right?
Yeah.
With straight lines.
I think so.
Right. But it's like it's idle time, right? It's
Mhm.
like I went and got a coffee, right?
Yeah.
Or a tea. Sorry.
Sorry.
And then
We're in
and
Boston. We have to be careful with that term here.
so I was able to get that sketch, split a face, and then rather than do a thicken out, I did a thicken in for a thick cut, right?
Yeah.
Nice.
So that's how I created that surface geometry. So there you go.
I love
Neat.
it, dude.
Cool,
That's but that is entering the mind of a surface modeler, and that is
but-
why it's so different than sub D modeling.
yeah.
And
But
it-
even just that, like that whole process, like there are so many ways to skin that particular.
Exactly.
cat,
Yeah.
so
Oh,
it's
yeah.
like-
Totally.
Yeah.
Like, because I surface model, and that is totally different, to
different
how
way.
I would do it. And I'm like,
Different than
wow,
how
yeah,
I do
okay,
it,
cool.
yeah.
I'm gonna let me make some little notes here.
Yeah,
because-
yeah.
And I think that is the variable wonder about surface modeling. There are many different ways to do it, and
Totally.
you know, in the SolidWorks environment, you
Absolutely.
do have a lot of options to do it different ways. You don't have to follow one strict.
That's
way of
why it
doing things.
exists. It allows you to determine how you want to piece the model together piece
Yeah.
by piece,
Yep.
because you're literally creating one face at a time and then blending those together.
Yeah.
Surface modeling is amazing. It's intimidating because there is so much flexibility, and it's not
Too
just
much.
follow this step, then this step, then
Yeah.
this step, then this step.
Well, also, you
and
get,
that's-
you get so far down the track with surface modeling, and you can trip yourself up. And be like, I just need to start again.
Yeah.
Yeah, that
I've been
does
so
happen,
far
yeah.
down
Yeah.
so many tracks with models where you're like, I'll just say goodbye to the last 2 hours. Let's
Yeah.
just start again.
Not gonna lie, that happens in sub D too.
Okay, yeah, sure.
Yeah, okay,
absolutely.
okay.
But
Like,
that's
what have
why-
I created? I need to just start over.
Yeah. And that's actually why I wanted to show like that roll through of the entire process, because of the fact that like the number one question I get asked about surface modeling is like, well, how do you even start?
Where do you start?
Right. Here's a
Always.
sketch.
Yep.
Right.
Yeah.
That's you know, so we start with this sketch, and I just wanted to roll through the whole process.
Yeah, I love it.
Cool. I love it. That's great.
It's a fun little journey to follow along. And like you said, Luke, every single person would have tackled it differently,
Yep.
but I think he did okay. So
Plus
On
one
to the
in
next.
chat for Andy.
the next thing that we had to do was actually create this mold. We
Yes.
designed the seat. My gosh, I'm gonna break it again.
Probably.
But we had to create this mold. And again, I'm thinking it was hard to bring my mind out of what I knew, injection molding,
Yes.
and be so flexible and so negligent of undercuts and things like
Well,
that. And
not
also,
even negligent, just embrace the undercuts. Like
yeah,
they're-
exactly.
They're kind of
Yes.
needed. So,
Yeah.
yeah. Like on this frame, we had smooth surfaces, so these little dimples weren't here to begin with. And the big issue is when we mate the two halves together, there's a real risk that silicon can slip or move. There's a lot of release agents
It's
in
a
here.
smooth
Things are
surface
lubricated,
and
it's
it
smooth, and they can
shifts
just
around.
they can just shift around. And before you know it, you've got misregistered parts, you've got bad seam lines. It's not what we want. So I came back and I says, look, the shape is great, but there are some refinements again, more design changes.
Originally, what I made was
Some more robust
basically
feedback.
this minus all the weird warp
Yes, yeah,
circles.
exactly, yeah. And I basically was like, look, we need some form of keying. Now the traditional way would be on your master pattern, you would either like cut little rectangles or triangles or stick some random things on the silicon while you're building it and then build a fiberglass shell. And you're left with loads of random protrusions all over. It's not very smart or very sexy, and it's actually not very durable for the silicon because you're typically creating quite harsh edges.
Yeah.
And so, like, I didn't even ask you to make these spheres. You just did it because it was the most logical thing to you, and it happened in this instance to translate really well into real life to being a good practical key, actually.
To be honest, the reason I did it is like I was like, well, it has to be easy to remove. I kept on thinking about the undercuts. I was like, a sphere is
my brain was that you were just being lazy because you can put the sphere anywhere and just do a cut.
Exactly.
That was my. I was like,
a sphere could go anywhere, and it's mostly
it's correct
to every positive
surface.
draft.
I like how it looks like you just did melon baller.
It did, yeah. It's just gone in there and just
stupid. Well, let me show you the modeling process because
Please.
that's exactly the feature I use.
The melon baller
melon scoop feature, new to 2025.
So this is this is a mold, and there's a part inside of it that was kind of floating inside there. But what I needed to do was create all these. I'm gonna hide these. You notice I use a lot of folders. This is one of the reasons. Like if you group common features together, it becomes very easy to suppress and unsuppress if you want to jump through different design revisions or styles and things like that. And let's just go through the process of creating one of those very quickly. So I'm going to cut a section view through here, through the center. And let's start a sketch on that plane as well. And I'm just going to draw a circle and kind of eyeball this thing, you know, about yay big. This is literally what I did.
Yeah.
I was like, I got to stop asking him questions. I'm too reliant. I'm just going to make the circle any size I want to make it.
Is that an unconstrained circle? I love it. It's great.
And yes, tons of underdefined right here.
Sure.
Brilliant.
But
this is okay.
This is a great reason to use an underdefined.
Yeah.
This is okay. Yeah.
But this is the art part. It's also why I like SolidWorks lets you do this kind of stuff, because there's often you just want a line where it feels right, not because it's 4.6 millimeters.
Right. Yeah. Seriously, a lot of it is just eyeballing it out. Because if you notice too, some of them are bigger diameters, smaller diameters. It all depends on like the space
where you put them.
Yeah, and where I put them.
Yeah.
Now the key thing here is to just uncheck merge result.
Yep. Okay.
Right. Because otherwise it's going to merge the two halves of the mold together with this solid sphere, and that wouldn't be a good mold design.
No, not at all.
So here it is just floating here. And what I'm going to do is use another, I think, way underutilized feature. We covered it in a different use case when we were doing the tree house design.
Oh yeah.
Yeah.
I forgot about that.
Yeah, when we made all the panels for
Yep.
the exterior like sheathing of how great for cabinetry and
Slug
stuff like
meat.
that.
Indent tips.
Yes. You can use it to cut off the overlap because there's a cut.
I have no idea you
checkbox
could
right
use
here.
this on curved, crazy surfaces like this. I
But
assume
yeah.
straight, plain sheet metal stamped things. That's,
Right.
I always
And look
forget
how-
that's what it's for.
Look how easy it is. Target body, you pick where you want to indent into, and then tool body region. So I could pick here, but I'm just going to have an easier time picking the region that's actually indenting into it
Okay.
on the outside surface. And then in just a few seconds, you're going to notice a preview.
Ta-da.
That does
God.
exactly what we want. I could type in the same wall thickness as the mold, which we chose 6 millimeters. And we
Which
can
could be a
even have
global
an
variable.
offset right there too, if we wanted like a little
like
air
you can
gap for
inflate it a little bit more.
Yeah.
If you have two parts that you want to have like a fit together, right?
Yes,
You don't
you
want
could
to be
have
the
3D
same
print
size.
tolerance in
Right,
the
exactly.
exact
You can put 3D print tolerance in there.
Exactly.
I love it.
And then that's all it is. It goes ahead and uses that body to create that. So easy. I'm going to do it one more time.
I'd like to say this is what I already do, but it's not.
It's much more complicated.
A lot harder?
A lot more harder than this. Like,
Well, dude.
Yeah.
All the things I learned from you
Yeah,
throughout
right?
this week.
yeah,
For
this
real.
is a learning for me. For sure.
I'm glad I can at least teach you one tip or trick.
Yeah.
From that point forward, you could either use move copy bodies to copy that thing into
Yep.
a bunch of different locations, or just draw those quick little spheres and revolve them
Yep.
on separate planes and do that process, and you're done.
I love it. That's
So
great.
so that kind of concludes the rest of the design, except for one very intricate detail, and that is, Andy, why don't you show us the pattern that you actually added to this seat surface?
Well, we said quite early on as well that because it's going to be a print and a mold, silicon can pick up almost any detail.
Yeah.
Like it can pick, if you dropped a hair on it and glued it to it, the silicon would pick it up. So I was like, we can throw some texture on there. And you're like, how big? I'm like you can have it 10 mil, it can be 20 mil,
Yeah,
whatever you want.
10 mil. I was like, what?
Yeah, not
Yeah,
mil,
I think these are like-
millimeter.
yeah.
And
I
so
think these are like 2 millimeter, but
Yes.
still it's plenty.
Yeah.
And like so the inspiration for this pattern actually came from Jason, who I won't say the name of the company, but it reminds with Gluey Breton, right? So if you've ever had a fancy Gluey Breton bag, it has a similar kind of pattern to the logos, right? So we utilized some of that. So the first thing I needed to do was I needed to kind of imagine, like, it's this curved surface, but the pattern's very like grid-like. So I needed to kind of drape this pattern down in here. So kind of walk through really what I did is just cut a plane, got a line, got a bunch of points on that line. From those points, created planes, used those planes to slice my surface. And then from that, I was able to, I kind of needed them to all be the same length, because to kind of make that piece of fabric, all the same, like that piece of fabric that's getting draped over it needs to be a square, essentially, for everything to line up in this like grid pattern. So I just extended them a little bit longer, divided them up, and then you'll see this odd even node a bunch of times, which is I want to grab every other, right? And this is just a complex every other of an every other of an every other, right? So it's kind of like mind numbing to like think about like
so many elements there as well. Like it's a lot to keep track of mentally.
Yeah. So if you look at like where each shape is like in relation to it, it's kind of, it makes sense if you stare at it long enough, which I did. I stared at it long enough.
Someone.
Yeah. But then I needed to get a bunch of vectors in there, essentially, right? Because what I'm trying to do is make it, locate it to the face, right?
And the face is constantly changing.
Exactly.
Yeah.
So what I was able to do is with every single point have like a Z vector, but then kind of define along that line an X and Y vector, right? So you can see what the I guess the Y vector looks like in this scenario. And I did the same thing for the X. So now every single point essentially has its own axis system.
You know what a Z vector is, right?
Oh yeah, Z. I'm sorry, Z.
Sorry,
I
Zed.
meant to translate.
Yes, please
Yeah,
do.
sorry about that. Yeah. So now that I have vectors for an axis system for every single point, now I could basically just take, I had to then take out which ones I wanted to put each logo onto, right? So this is actually the DS logo. And then the DS logo, I need to create the surface for each one. So I do that here. But what I actually needed to do was grab the initial one. So that seed is actually just a surface that I dropped on there. I actually did that this is another cool trick. You can actually grab a picture and say, pull the contours from it. And it grabs points at every contour and then puts a spline around in between them. So another cool tool to take a picture and turn it into spline geometry that was on a surface. And then what I'm saying is for each one of these, I am just taking that and then applying it to this axis system, right? And then scaling it appropriately, right? And you could scale them however you wanted. Now you notice there's the red there, right? It's like, red means there's an error, right?
Red dot.
Gosh, that's not good. Well, it's just because when I'm trying to project it onto the surface, not all of them hit the surface, right?
You made your blanket, so to speak, bigger than the actual seat.
So it's giving me an error. Luckily, in XGen, there's a remove error node, which I love telling you about.
Can I have that in SolidWorks?
Yeah, it's just like
Just remove
when
error.
people figure that out, they're like, they think I'm joking with them. I'm like, no, it's type it in, remove error. Like it just takes all the error ones, all the ones that error it out of your list, and you can move on with the ones that did not
Take that
error.
in SolidWorks and in life.
I feel like I've been cheated in all my years in SolidWorks. This
Right.
feature, like.
Yeah, so after that, it's pretty much I just slice the faces and then thicken it, right? And then the thicken turns into a particular height off of it. So it takes that, wraps it onto the surface. The project actually works really well. This isn't a 2D project. This is like a wrap project.
Right. Nice,
It's
yeah.
really cool. So that's why all the DSs look like DSs. They don't look like
Yeah, I was
squished.
really
Which we
impressed
do
how it
have.
got, like,
We
in
have
the-
that wrap feature in SolidWorks, but
Yeah,
we
yeah.
have to create a unique
Individual
plane,
ones, yeah.
for every single
Well, I was
instance.
impressed, like even the ones in the crazy like compound corners where it's like there's
Exactly,
like 4
yeah.
or 5 different axes of
Totally.
of like
Yeah,
change, and I'm like,
yeah.
how is he doing that? Like
Right.
I had no idea how you
Right.
did that.
Yeah.
Once
So-
again, not how I would have to do that.
Exactly. Yeah. So anyways, that's pretty much how we did it in the end. You can see here the thickness of it, right?
Crazy.
wrapping around that corner. So 2 mil off of
And
the
again,
entire
he didn't draft the edges. Who cares? Silicone.
Doesn't matter, 'cause it's silicone.
Happy undercut.
Yeah.
Yeah, exactly. Yeah. And the
Just
great
pop
thing is
right
with
out
the
of there.
master, as long as we get a clean enough master or spend our time cleaning it up, we're going to pick up all of that detail, no problem. So yeah, it's great.
It's the coolest manufacturing process. I think that
before we jump out of the seat, I did want to say we're
Literally.
put a +1 in the chat if you think that Dan Wagner should do share a file on this. So anybody that has a maker's license will basically be able to get this in XDesign, see how it's surface modeled, and print it out. Right? You can print out your own big SolidWorks logo, scale it down to your bed size, whatever you want.
I think that's a
I
good
guess
idea.
you could even share it with the orientation with the supports we did. So
We
people
could, yeah,
try
we
that
can
at
share
home.
both. Yeah, we can
because
share it with Justice and then also the one with the supports.
Yeah, that'd be great.
And then you have an
They just
example
hit
of how to
print.
do those breakaway supports. Yeah.
Yeah.
I want
Super
one for
cool.
my office at home. So
Great.
share it.
I
vote
will.
Yes.
Yeah. So all right, well, Dan
+1.
Wagner. If we get enough in the comments, we'll do it.
Nice.
All right. Well, guys, that was the. Oh wait, let's reveal the seat.
Yes. Let's reveal the seat.
Right?
So I
Yeah,
made,
where is it?
Let's
I,
sit in
I
it.
made I made the mold at the scale that we required because metric and imperial.
Oh, we had a little
had
like Hubble telescope
miscommunication.
mistake.
I mean, all I saw on Zoom was these trikes. I thought they were the little finger bikes, and then but now we have a lovely throne for a CAD hand, basically.
Oh, nice.
When you're tired, surface modeling all day. So
Yeah.
we've kind of made some rough plans that we're going to bring this to life at World.
Yeah.
And so I think we're excited. We're going to do some talks about it and some demos. We're even going to run this mold live at World. And let me tell you, running foam is a chaotic process. So if you want to laugh and want to see many failures, it's definitely going to be something to watch because we basically have 15 to 20 seconds to mix the foam before it starts expanding 6 times its volume. So you imagine you've got a liter cup and you're just like mixing and then suddenly it'll be fun. So come along to the makerspace in the booth. We're going to have that mold there ready and we're going to have some fun doing it. So Andy will be on hand to laugh at me while I do it.
Absolutely.
And
And we're going to try and do a session where we go back into gritty details of all of this stuff that we talked about today.
Yeah,
and if you're
absolutely.
there live, you can ask questions. So it'll be great.
Yeah. So I just saw Suchit walking back there. I'm sure he's on the executive board user session approval group. So like now you got to approve that one.
We just got to approve, guys. It's going to be there.
All right.
It's great.
All right. Sign up for that one. Haven't even submitted the session yet, but it's approved.
Great.
All right. So, guys, that was the last stop on this huge tour of this crazy collage of all these parts coming together and actually looking really slick.
Yeah.
I couldn't believe, I thought the aesthetic was going to conflict from one to another. And it just came together, and
I think so. I think it looks really good.
I think
it's,
it looks
it's also
awesome.
so much fun. I forget the visuals even, just to ride it, and you guys at home will only get a taste from seeing it. And I got this feel when I watched you guys doing the demo build, it looked like a lot of fun, but not the same level as actually going on it.
Yes.
And so it's you can. I'm sure you guys have the capabilities to do this at home. All of this is make a hobbyist expanding into more professional stuff, like you guys said.
Yeah.
And with services like Send Cut Send and people who've got water jet cutters, all of these things are within reach. You just got to go a little slower and be a bit more creative about who you connect with. And so for me, this is a very approachable build for someone who is motivated to want to make something cool. And that's, for me, that's what making is all about.
Yeah, and let us know if you like this trend that Slug Me is on, focusing more on maker stuff, because we want you to use these SolidWorks licenses to actually build. And the gap between pro manufacturing and maker manufacturing is getting smaller and smaller and smaller every year.
Well, printers are getting faster, they're getting bigger, they're getting more capable.
I couldn't believe how fast these printers are. This is the first time I've seen one in person. I was like, is this thing broken? Is it about to catch on fire? It's going so fast.
Well, there's services like obviously you got 3D Print UK, you've got all the Craft Clouds, all the other ones that are just big print bureaus where you can go out there and just get things bigger than you can even do at home. And they're so cost effective these days. It's you can expand your capabilities in your own shop by augmenting them with things externally. And I think you don't have to have all of the tools yourself. You can go out there and engage with suppliers. It's fine. And they're also a lot more accommodating to makers these days. I'm finding like
Mhm.
in the last 10 years when I started, you'd speak to a machine shop, they just laugh you out for asking of two of anything.
Yeah.
Now
Yeah.
they'll speak to you and you
Yeah.
can have those conversations. So the landscape's changing, and I think as an individual maker, you just have to go with it and just enjoy it.
I appreciate it, man, and I learned so much from you. Thank you
Thanks.
so
Yeah,
much.
me
for
too.
being a
I did
part
too.
of it.
Thank you very much.
And I hope you guys at home learned a bunch of stuff as well. There is so many cool new workflows that like really opened our eyes to how you could build stuff. And I think the trend's just going to continue next year. As long as you guys say you like it, we'll stay the course for sure. So let's wrap this show up. Dan, I think you. Oh no. Okay.
Let's unwrap it.
Unwrap it. What we need to do is more simulation.
We're gonna leave.
Yeah, we're gonna get out of the way. This next guest is too smart for us, so we're just gonna make room.
All right, everyone, we are almost towards the end of today's session, and what I want to do is end it on a simulation load. I want to show you something really exciting that I have been keeping myself busy as these guys were wrapping up the manufacturing and making these trikes ready for us. So what I have been working on is a very interesting kind of simulation. We call it, in the simulation world, we call it a coupled thermal structural analysis. What you see on the screen is basically a brake rotor. So in a system like this, the way things work is you have mechanical force from the driver being converted into the pressure, hydraulic pressure, and then the brakes pad get actuated. And basically, as it clamps onto the disc, it creates friction. Due to the friction, it absorbs energy from the brake rotor and it converts into heat. So some of these complex simulation we can now do integrated within the SolidWorks user interface. So this is a classic example of a multi-physics scenario where my thermal solver is working in tandem with my structural solver. And not just this, right? I can simulate scenarios like thermal, structural, electrical, electrochemical, and we can couple some of these scenarios together as well, which makes for a classic multi-physics simulation. So I kept myself busy in studying some of these complex physics with some of our subsystem in an effort to optimize some of these in the future, and that's basically what you're seeing it here today. Now the key takeaway is, as I just mentioned, right, we have these great capabilities now with integrated with the SolidWorks user interface. All right, that's pretty much it from my end. I know what you guys are waiting for. I am certainly excited to see some of the footage we have from the trike in action, basically, drifting it around the parking lot. I'm super excited to see what we have. So I'm gonna turn it back to the crew to play this video.
I'm hearing some noises out of this thing. I don't like it.
Oh, it's the brake. Look, the brake is riding on the caliper.
Oh, I'm just slipped. Does this
Yeah, it must have slipped. Does that mean the whole thing's sliding? We need a hammer. I didn't bring a hammer.
We got a sledgehammer.
Let's get it.
You guys. Oh, then we'll take that. Totally precision, totally normal.
Don't worry about this.
Yeah.
It's normal.
What do you think?
Pretty cool, man. It turns on pretty fast when you brake.
What'd you think?
It was awesome. Lot of fun. Little control, but a lot of fun.
Don't mess us up there. I thought the fun was talking. Like,
All right, everybody. This has been an awesome day. Crew, I want to thank you all so much. Slug Me 9 was an absolute blast. Let's hear it for the crew. So we started the show today with a couple of reminders. The first, join our new LinkedIn group. We have an awesome new space for any user group member to collect kind of between meetings, right? Collaborate, connect with other leaders, other members around the world. Scan the QR code. Check that out now. Go to the next slide here. Let's not forget the maker's offer, right? This whole thing was surrounding kind of the idea of the advanced maker, being able to build something like this in your garage, sourcing vendors, working with partners, collaborating with an awesome team. You could do something like this. And the maker's offer is a really great solution for you. And don't forget, there's a discount code in the description for the video today, 20% off for any Slug Me 9 viewer.
And whatever you do build with your maker offer, make sure you share it in the Maker Made in 3D community.
Yes, absolutely. For sure. And as we kind of wrap up this huge event, our next huge event is 3D Experience World. We're getting ready for 3D Experience World in February in Houston. I know most of this team is going to be there. We hope you can join us. Registration is open now. Please join. I love the idea of that seat session as well. Sounds like you already got the approval from Sujit, so that's good. But anybody else? Todd, I'm going to go to you to take us out here, man. Slug Me is your creation. What do you want to say here at the end?
Come back for Slug Me X.
Slug Me X. All right. Thanks, everybody. Have a great day.